Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
Are you ready? Debate fans, are you ready? For the handful in attendance and the thousands watching across the world, brought to you tonight by Jeranism, the #1 YouTube channel in all of existence. Ladies and gentlemen, let's get ready to rumble!
Make sure your argument is tight. Babe, what? You must got proof if you so right. Babe, what? Don't get dismissed on false claims, cause you gotta bring the truths and the facts. It don't matter if we talking about racism, sexism, scientism, paganism, socialism, communism. Talk about capitalism, atheism, globalism. What about creationism? It don't matter what the ism. Live on debatism.
Welcome, everybody. It is time for Debatism. We are on to episode number X6, I believe. So don't get it twisted. We've got, let's see who's going to join us today. We've got episode number X6. We've got MCTOON and Craig, FTFE, against Dave, Sovereign Soul, and Flatzoid's perspective. They each chose a subject before the contest. We've got Bottom Up Obstruction was chosen by MCTOON and Craig, and Gas Next to a Vacuum chosen by Dave and Flatzoid. Each team will have 45 minutes, and they'll each have 2 buzzers that they can ring in if they want to take over control. Let's bring the boys on and say hello to everybody. Let's get them over here. There we go. All right, first we got FTFE. Say hello and all that fun stuff.
Hello, hello, hello. How are you doing? Thank you for having me. If you haven't seen me before, you can find me on the YouTube channel, youtube.com/FTFE1, and over on X, FTFE Official. This is going to be fun. Thank you very much.
You're welcome. We also got your partner, MCTOON. MCTOON, how are you?
That's right, MCTOON. Thanks for having me. You can find me on MCTOON Live or Conspiracy Tunes on YouTube.
Awesome. And we've got Dave, Sovereign Soul, Unchained Mind. Dave, how are you?
Well, I'm doing very well. You can find me at Sovereign Soul Unchained Mind on YouTube, also at SSUM369 on Rumble.
Okay, and we've got your partner, Flatzoid's perspective. Flatzoid, how's it going?
Yo, Fluffs, good to see you guys. Yeah, you can find me on Flatzoid's perspective, Twitter, Instagram, and YouTube, obviously. Thanks for being here.
We should just own that one so that we can just, make it funny. So you're right. We should just call each other Flurfs and each take a Flurf name. It's probably the best way to do it. All right.
Let's make it cool.
Let's make it cool. We'll have Flurf jerseys. It'll be very cool. All right. So we're going to start out with a quick coin toss, and then we're just going to go with 1-minute intros for each person. And then whoever wins the coin toss can begin the conversation. So let's go with oops, let me get this on there real quick. The coin screen. And it is not able to be seen. There we go. All right. So let me get that on there. And it is here. Good. Let's let the visitors go first. Sorry, Craig, you get your face covered for the coin toss. My bad. Who wants to cover it? Go ahead and call it MCTOON. Do you want Debatism X or modern day debates?
Debatism X, of course.
All right, I would hope so. Let's see. Is it going to be James or... Yeah, nice one. All right, you win. So it's going to be you guys first. Go ahead and do your minute intro first. Each get a minute. We'll start with... Let me get that off the screen. My bad. There we go. You're back. Oops. You're still my back. There we go. And Craig, you want to go first?
Yeah, thanks. So we are going to be talking about what bottom up obstruction means on the Earth and how we can predict it and calculate it and the implications of it, and how it shows that the Earth is a globe. The evidence is quite simple. Observations that can be repeated and seen every single day. The concept of the Earth being flat is so easily debunked just by looking at things, frankly. And that's the only introduction I really need.
Okay, MC Toon, you got a minute? Go ahead.
All right. Well, as Feynman said, the essence of science is in testing a hypothesis. You compute the consequences of that hypothesis and compare to observation or experiment or reality. And if it doesn't match, it's wrong. So we can compute the consequences of what the globe says, and it matches every time when you can include confounding variables. And I've never yet seen a flat earther present a way to compute the consequences of flat earth related to bottom-up obstruction. We definitely see it. We'll get some examples in a bit. So I'd love to actually hear how you compute the consequences of it. What is the actual number of feet obstructed predicted by flat earth, depending on the height of the observer, the distance, or whatever factors are at play? I'm curious and I'm anxious to test the hypothesis.
Excellent. Thank you very much. And we've got, let's go ahead. Dave, you got a minute? Go ahead when you're ready.
The heliocentric concept dies upon inception due to basic physical natural law. Nowhere in nature or in a controlled environment can we ever produce a volume of gas outside of containment. Never has gas been seen or evidence to coalesce together into a mass, much less into a mass so large that it would cave in upon itself and cause nuclear fusion. This demonstrates that the whole concept of a heliocentric soul lure system that we live in is dead upon arrival. There's no demonstration of gravity, much less gravity having any kind of an effect on gas behavior whatsoever. They'll point to a gradient, of course, but we have a temperature gradient. And as everyone knows, the pressure of a gas will decrease as temperature decreases.
Thank you, sir. And we've got Flatzoid. You got a minute when you're ready. Go ahead.
Okay, yeah, well, it's actually very simple. Bottom of the line is the globe is based on faith. Every time we have to ask for demonstration for any of the claims, it's based on, just trust me, bro, Earth too big. What is it? We don't know. Just show us for flat because we need you to replace our burden of proof. And yes, the globe has the burden of proof because we do not observe gas pressure without containment. We do not observe physical curve. What we do observe is optical effects, and what we do observe is we have containment to have the gas pressure. And yes, gravity is not a force, so you can't even play gravity as a force for gas behavior because, according to physics, gravity has no effect on the direction of gas. And that's all I have to say. Thanks.
Thank you very much. All right, so you guys can choose. I'm guessing since you won the toss, you want to start the conversation. You can talk about whatever you want. We'll start your clock, and then remember, you guys are going to be on mute, Flatzoid and Dave, and then you can ring in. Go ahead and hit your buzzer just so we can make sure that works. One of you, somebody hit it, and we will make sure that it is working. All right, thank you very much, FTFE. And so when you buzz in, remember, I'm going to count 10 seconds, and then I'll switch the mute button from your team to the other, and we'll continue on. So that's basically...
My buzz needs to be reset.
Yes, they always will be there. Now, everybody, you can try yours again if you want. Or you feel good. Try it one time, Dave. Just make sure. All right, we're good. Now I'll reset.
Oh.
Okay, so everybody's works. We're good. All right, let's get rolling. We've got you guys on mute. See you, Dave, and see you, Flatzoid. Good, you're on mute. Okay, so go ahead. You guys are ready to begin when you want.
I can start.
Yeah.
I'll share a screen here. Is that ready?
It might
Jaron?
be kind of, sort of. No, not really. Yes, I'll get it on the screen. It's just it's gonna be the whole screen for now. I don't have you guys on there, but it'll be there shortly. But you can go ahead and start, and I'll fix it.
All right, is that up?
It is now. No, not yet. Oh, hopefully I didn't do anything wrong there. The clock still work? Okay, good. And the clock, we'll give you 5 free seconds there. It's going to be me for some reason on the screen. Just have to deal with that. All right, I'll fix it. It is on the screen now. Go ahead.
All right. Well, this is about the pressure and temperature differential that doesn't match. Sorry, we'll get to that later. Okay, here is the Seattle Ferris wheel right there, nice and close up. You can see below the Ferris wheel is a dock, and there's some structures around there. But from a distance there, the bottom is obstructed. Where did it go? Something is missing there. So something is causing the bottom-up obstruction. I have never heard an actual physics and optics-based description based in reality and on the known laws of physics for what causes anything, how a flat surface can get between an observer and a distant object when both the observer and the distant object are above the flat surface. So I'm anxious to hear about that. Anyway, here is it can't be zoom. It's often claimed that zoom will bring things back. So here's a boat. You can see on the left there, that boat, that ship is obstructed. All you see is the top of it, the superstructure. And when it zooms in more, same amount of superstructure, it doesn't actually change how much is ever blocked, no matter how far in you zoom. Now, I tested this myself right here with the P1000 on Pensacola Beach. You can see here's my location, GPS location. And there on the left is the photo zoomed out all the way. You can see the boat. You can see the superstructure of a boat. It's a fishing boat, and the where they hang out and stuff. But you don't see the hull. You don't see any of it. There's partially zoomed in, and here's all the way zoomed in using the full optical zoom of the P1000. Did not unobstruct any of that boat at all. None of it was unobstructed. Further, also in Pensacola, I did another test here. Here are two photos you can see on the top is my my iPhone. And on the bottom is the Nikon P1000 fully zoomed in, and the exact same amount of the buildings are visible. And I even did an analysis of the angular resolution of both of those cameras. The aperture diameter of the P1000 for the f-stop of 8 value, which is in the metadata for that photo, 67.4 millimeters aperture diameter, giving an angular resolution for 550 nanometers of 0.00057 degrees. Pretty decent angular resolution. The iPhone camera that I was using, iPhone 13 Pro Max, the aperture is 3.36 millimeters, and the angular resolution at the same frequency is 0.01144. So degrees, a significant difference in the angular resolution capability of these two optical devices, yet they both see the same amount. So the zoom didn't change it. The angular resolution didn't change it. Nothing changed the amount of blockage that I have been able to determine, other than being closer or being at a higher elevation. So, all right, Craig, you got anything?
Yeah, just a similar observation, really. Now, I'll just put it on my camera so Jaren doesn't need to put it full screen. Just this.
Oh.
So, Tampa Bay. Is this being seen, Jaren?
Yes.
Yeah. Right. So this is Tampa Bay in Florida, and this is a picture taken up close, right? And then looking at the same buildings far away, and just like Toon said, the bottom of them disappears, and zooming in doesn't bring them back. The only thing that brings back the bottom of these buildings is being closer to them. So there's a physical blockage here, something physically obstructing it. And this is the norm. This is the observations that you would normally get. Refraction is a thing and can change the apparent position of things. But in general, the normal position is the bottom of things are disappearing, and no amount of zooming will bring them back. Things like the black swan is just effects of refraction, which we fully expect on the globe. So to try and say that it debunks the globe, it is frankly just a straw man of the globe. So Toon, that's pretty much all we need to say about that. I guess we'd like to hear their...
Sure, I will go ahead and put them on. Go ahead, you guys are on, and you guys are muted.
You want to go first, Keith?
Are we gonna present, or are we gonna actually rebut it now?
I guess we rebut
Okay,
it, right?
rebut it. Okay, it's very simple, guys. First of all, if you understand your first image of the Ferris wheel, by the way, Mike, you showed compression, and there was at the bottom there you could see the compression band due to the mirage. Yes, you do get parts where you cannot zoom in because you have what we call limited angles. Just like the boat in the background that you couldn't zoom in, we can say simply just due to a swell, a little wave that is foreshortening thanks to perspective. There's many optical effects at play, not just one. When you bring up your angular resolution and you show, okay, look, based on angular resolution, it should be shown, but it doesn't. So therefore, earth curve, once again, we can show you on flat surfaces where we do have bond of obstruction, thanks to sky freeze demonstrations. Terry Riker even brought a video up. I was looking for it now, but I couldn't get it in time, where you literally see a boat go behind and it goes in a swell up and down. Also, you're ignoring parallax when it comes to that. The further away something is, the longer it's going to take for that to get out of the swell, or that swell to get out of obstruction. It's just simply angles with optical effects. How can I put it this way? When you guys fight for refraction and optical effects, it means it's not physical. That's all I need to say about that. You can
So what you end up with is, I just want to show this real quick. Wait, let me get the right one. There we go. All right, so this is your field of view, both from a top-down plan view and also.
Okay, we're taking them out. Go ahead, FTV.
Yeah. So, I just Flats, before anything else goes on, I would like you to clarify what you've just said about if it's refraction, it's not physical, and explain how you can have a refracted something without a physical thing. I'd just love you to expand on that because I don't feel like just saying that was a rebuttal without an explanation.
Okay, it's very simple.
Oops, sorry.
It's not physical. The position of the object is optical. So when you claiming, look, it's blocked by physical earth curve, it's not. It's optically blocked because of optical phenomena.
So back to what I was saying is that your field of view is at about 70 degrees down. You can see up to your line of sight just below relative to eye level. You're going to see a horizon. No. And you're going to see a horizon. Okay, now what happens at that horizon line, because the ground stops appearing to elevate up, and now you're looking at it straight across in a planar view. This means that your field of view is now compromised by the horizon. And as everyone knows, things that go away from you get smaller in angular size, appear to get smaller. And this is going to appear to happen from the bottom up because of your limited field of view. Now, Mike said earlier that if you go higher in elevation or closer, you can see the bottom of the obstructed building. That's exactly right, because now in both of those cases, the bottom of the building are now within your field of view. They're not obstructed by the horizon. You basically, your field of view is cut in half once you reach the horizon line. So if you increase in elevation, you'll see the distant object. And if you increase in elevation more, you'll not only see the distant object, but you'll also see the more horizon beyond it, because the horizon is nothing more than apparent. It will always rise relative to your eye level. And that's all I got on that. How do I do that?
Keith, anything else?
No, that's about it. It's just simply they don't understand that things are optical.
Okay, we'll switch
the reason
over.
why we see it.
Go ahead, FTFE, Toon.
All right, could you show measurements, and of course, not calculations, measurements that you have done or somebody's done of the horizon rising to eye level at some high elevation, please?
Okay, you're unmuted.
Simple. It doesn't matter which distance you are, it rises relative to eye level. That means due to perspective and convergence, no matter your elevation, you'll always have the horizon relative to your field of view. Therefore, not physically dropping down, optically rising as perspective dictates. And
but
the
could
measurements.
you show some measurements? Yeah, some measurements.
Yeah,
please.
your theodolite measurement you put on your side. There we go.
Let's see them.
Go on your side. Show yours that you always show everybody within the horizon.
Yeah, bring up the measurements. Yeah, bring up the measurements of the horizon rising to eye level.
That's called burden of proof, by the way. That's burden of proof.
You made David made the claim. Yep, it's burden of proof on David. So David said the horizon rises to eye level. I just want to see the measurements of it. Yeah,
well,
show the measurements of it.
We don't need a measurement. We don't need a measurement. It's evident.
Oh, you don't have any measurements? Okay. I was kidding. I knew you didn't have any measurements.
Mike, it's evident. It's evident. It's evident. It is well known and been demonstrated on AutoCAD and other such programs that if you rise in elevation on a sphere, given the radius that we're told that the Earth is supposed to be, that the horizon will start to drop and to a point where you have to look down at an angle to it. You don't have to, no matter the elevation that you go to, as is demonstrated by my background.
Yeah, I've got an idea. Can you guys show us one picture where you don't see the horizon no matter what altitude you are?
Is that a question for them? Okay, you're unmuted.
Okay,
right,
so
sweet reversal there. I just want a measurements supporting your claim, David. That's all.
Yeah, and just first, to say it's well known, so we don't need to provide evidence, is literally just avoiding the burden of proof.
Yeah, run away if you don't have any. I get it.
Made the claim, have to provide evidence for it, and it's known. It's well known, documented and measured that the horizon drops the predicted amount by the globe. It doesn't rise to eye level or relative to eye level, whatever that attempt of getting out of specificity actually means. It simply does not. The horizon physically drops from eye level with altitude. This is a fact. So, Toon, could you just ask your question again, and then we'll pass it back to them.
Yep, I just want a measurement supporting your claim, David, please. Thank you.
Okay, you guys are unmuted.
Been outside. Apparently, neither of you have ever been outside or experienced anything in reality, because I don't know what the fuck kind of a measurement you're expecting to have when there it is. It's apparent. It's apparent. Whereas your claim, Craig, where you said that was the only way is by going higher in elevation or getting close. No, it's not the only way. You always have these absolutes, and that's not true at all. You can, all experiences tell us and show us that the horizon is always relative to eye level. It's always just below your eye level where you're looking, dependent, because you're standing on it. You've got height. Okay, so it's always going to be there. I don't care where you go. If you're sitting level, the highest elevation you go to, you're not going to see any drop of the horizon. It doesn't occur. So you're just stating lies.
Yeah, I got some questions. Can you give us one altitude where you wouldn't see the horizon relative to eye level? Because you guys are claiming it shouldn't be relative to eye level. So that's why it's you guys reversing the burden onto us, when you cannot provide us evidence that there isn't an instance where you never see the horizon rise relative to eye level.
Passing it. Okay, you guys are good. Yep.
All right, I'm sharing my screen here. If you can put that up there, Jaron.
Sure.
But to answer that question, at 200,000 miles above Earth, you wouldn't see the horizon.
All right. So again, David claimed the horizon rises to eye level. David has the burden of proof, not me, not Craig. David does to show that happening, and so far he has been unable to. That's definitely waving the white flag there. I appreciate that. Thank you very much for not being able to support your claim.
Yeah, but I guess we're just going to ask once more to press this home. David, can you please provide us with measurements of your claim that the horizon always rises relative to eye level? please, just measurements, not words, not saying it's evident. Just the measurements, please. Over to you.
Thank you.
Measurement are you looking for? What kind of a measurement other than an observation that occurs with everyone would you even be looking for? That's retarded for you even to ask. In fact, it shows the desperation that you have right away. It shows what desperate. Where's your numbers? Where's your math? You guys are pathetic.
Okay, I've got an answer to that. What elevation is your photo taken there? What, 200,000 feet?
Yeah, 100.
Okay, there's your math.
127, I think.
Great. Okay, 127. Well, even at 200,000 feet, even at your beloved space tin floating in a natural violation called space, you still see an horizon, apparent horizon, due to its relative position. So, again, you guys are telling us that there is no measurement at any altitude for a apparent relative risen horizon, which is not physical, it's optical. You guys will have the burden on you because you claiming there is none, yet doesn't matter which altitude in history, doesn't matter who's gone any higher, there has never been one instance not observed having a horizon relative to eye level. If you don't understand what relative is, we'll be more than happy to explain it to you, but don't play dishonest games, Janto. Give us the math. Fine. 200,000 miles up, 200,000 feet up. It's still there, like it should be predicted. No matter how far you're up, it's going to be there. The burden is on you to show us where there is an instance where there's no horizon relative to eye level, which is impossible.
Should be able to you should be able to show it dropping with an increase in elevation. You should be able to see it show the horizon dropping down to match the supposed 8 inches per mile squared of curvature. And we don't see any of that.
Want to pass it?
Yeah.
Okay, go ahead. You guys are on.
I don't know about you, but I failed to see the measurements there. Did
I saw no measurements. And when we said measurements, they repeated back the words math. I didn't say math. I know that David only would ever do a measurement and he never does any calculations or math when he does a measurement. So behind him on his screen, there's no measurements there. We don't know where eye level is in there, so there's no way to identify whether or not the horizon rose to it. Is it the center frame? Was the camera tipped up? Was the camera tipped down? There's nothing there. Very confusing that David and Flatzoid are running so hard from actually supporting their claim.
One thing I did notice, though, Flatzoid offered very kindly to explain what he means by relative to eye level. So I think what would be appropriate at this time is if we ask two things. One, we would still like to see the measurements, but on the back of that, Flatzoid, please do give us that explanation of what you mean by relative to eye level, because obviously we don't want to strawman you, do we, Toon?
So let me say this. I would love to see the computation of the consequences for the globe that he did, because they have been saying that the horizon doesn't rise, or that the horizon does, and it doesn't match the globe, right? They say that doesn't match the globe. So how do they know how much the globe should? Certainly they did this application, the computation. So for, say, 11,000 meters, you two, what is the globe's predicted angular dip, and what is the flat Earth's predicted angular dip at 11,000 meters? Let's see it.
So that's three things. One, the measurements. Well, the specific one, there's two.
They won't have that. That's silly. They won't have that.
I would really like, though, Flatzoid to give us the thorough explanation of what relative to eye level means, because I never. Yeah.
For the globe, because he doesn't want to strawman the globe. So whatever relative to eye level means for the globe, let's have it, Flats.
Please, Flatzoid, over to you.
Okay, you guys are unmuted.
Okay, so real quick before you go, Flats, I'm gonna put it at this. Okay, here's your what it's predicted on a flat Earth. Okay, is that there's not going to be a change in the horizon line relative to eye level at an elevation. Okay, and so it's 0. That's what's predicted there. What is shown on a globe? Nothing at all. So it doesn't even matter what it would be on a globe because it's not fucking there. Go ahead, Keith.
It's very simple, guys. You guys are trying again. You see, this is all the guys do. I have a burden, but I have to place it on the flat earthers because what was the claim? You guys claim to always see the horizon relative to eye level. Yes, we do. No matter how high you go, you always see the horizon relative to eye level. Oh, but we want to claim it's supposed to be dropping. So it's your burden to prove to us. Okay, simple. 200,000 feet, the horizon is relative to my eye level. And by the way, relative is just based on position or argumentation place. Okay? Now, again, the math you want to claim on your globe or the flat earth is your burden because you're the one making the claim. You need math for it. We don't need to claim math. We're literally saying, here's a photo, here's the horizon, which you claim shouldn't be there. So therefore, it's your burden to prove why it should not be there. Not us to prove why it is there, because it is there.
Passing it.
Yeah.
Go ahead.
I didn't hear an explanation of what relative eye level
Yeah,
means.
there's nothing there. But let me say once again, hold on, Craig, if I can. They made very specific claims about the globe. Very specific. They then have the burden of proof to show what they did for the globe. They said, correct me if I'm wrong here, they said the horizon doesn't rise according to the globe the right amount, right? So they must have done the computation to know how much the globe should rise or not rise, and then compared it to an actual measurement. So far, I've not seen them do that because there's an actual real number that the globe predicts from 11,000 meters. And certainly they must have handy the ability to do that to apply the globe. So that's what I
And of course, they don't want to strawman the globe. They wouldn't want to do that.
wouldn't want to do that.
Oh, and I did hear a buzz. So
Go ahead.
Sweet.
Yeah, again, it's called the black swan. There's your measurement. We've seen many flat earths. Yeah, we've seen many observations, low, high as well, that go against what your globe says and show once again what you're fighting for is optical, not physical. Notice how you guys have still not yet been able to demonstrate how the horizon is physical and still have not been able to demonstrate how the horizon does not rise relative to eye level. All you are trying to do is reverse the burden onto us. Now, are you going to man up and say, yes, the horizon is not physical? Or are you actually going to provide us any instance where you do not see the horizon rise relative to eye level? Thank you.
Anything, Sovereign?
Yes. As far as, what is it supposed to be for a globe? Look, if it doesn't change at all, that tells us that it's not a globe. It doesn't matter. If it doesn't change at all, and yet you're going to talk about bottom-up obstruction when you're standing on the ground, but then when you go up, oh, you still can't see it up at this high because it's too high, it's too big. Come on, pass it.
But that not just that, and it does change constantly, even at ground level. That's the whole point. It's optically changing position. That's why we brought up Black Swan now. So you can't claim it's physically changing. It can't. It's optically. So therefore, if it's optically changing due to optical phenomena, you can't claim, hang on, it's a physical curve.
Passing?
Yeah.
Go ahead.
That's just, I don't want to strawman you. I feel like I'm unable to respond unless Flatzoid gives us a specific explanation of what he means by relative to eye level. So,
he's strawmanning us. We don't claim the horizon would be relative to eye level. That's not our claim. I'll be very specific. My claim for 11,000 meters is 3.4 degrees plus or minus 1/10 of a degree. That's my claim for the horizon dip at 11,000 meters. All right. So let me show you. Let me do what they are unable to do. And Jaron, I'm sharing my screen there.
Okay.
Here is a measurement from an airplane at 11,074 meters. It's measuring. This is a measurement, a dip of 3.3 degrees. The globe prediction is 3.4 plus or minus 0.1 degree. There you go. it dips. Not only does it dip, completely falsifying David's initial claim that the horizon rises to eye level, and completely invalidating Flatzoid's straw man of the globe of it relative to eye level. It's a very specific amount that we predict, and it totally matched.
Go ahead.
Okay. Can I just quickly say something before I miss my thought? Yeah. Was he able to replicate this with the same height on a different day with different atmospheric effects? I don't know, but yeah. By the way, you're still showing it to rise to relative to eye level. So look at, no matter what altitude he's going, guys, can you see the horizon still in view relative to eye level? So in other words, Craig, just like I said before, clean out your ears. Position relative. Yeah, there we go, Dave.
So here's a time lapse. We don't even have to listen to it. Here's a time lapse over a period of time. Notice how we're getting all kinds of different compression artifacts. We're seeing the horizon even in the background. Of course, it's going to move a little less than what's in the foreground because of parallax. But is the Earth breathing or what's going on? We're getting a different horizon all the time, aren't we? We're getting all the time. It's moving up and down due to diffraction, refraction, atmospheric conditions, temperature. There's a whole host of factors involved there. So let's see, let's stop. There we go.
Yeah, I also have something to share quickly.
Okay.
Because they don't believe us that everything is optical. And quickly just share. How do I share now? At the bottom.
Should say share screen. I don't see it yet.
And refraction. There we go. Is it showing?
It says you start. Yep, there you go. We got it.
Okay, guys, you see these are buttons on the floor. Look what happens when we introduce refraction. Tell me where the horizon is when this happens, please. This just shows you once and for all. Again, it's optical. Refraction caused it to look curved. It's as simple as that. You have not yet to show curve is physical. And I can see they're trying to run our time down on optical effects because they're too scared to move to gas pressure without containment, just to let you know.
You guys can move on.
I think we beat this to death like a dead horse. I mean,
yeah, it's optical.
It's your guys' control. You
can move wherever you want. The impossibility of gas pressure without containment, or even having a volume of gas without containment.
They haven't even addressed this topic. Can a optical phenomena be physical? Okay, yeah. So I think we healed.
You want to yield or?
Yeah.
Okay. Go ahead. You guys are up.
Well, just to clarify, whatever you mean by relative to eye level is irrelevant because the horizon drops a measured amount from eye level. Yes, you can see the horizon. It's predicted that you can still see the horizon, but it drops. It physically drops as you rise in altitude. It doesn't stay the same position relative to your eye level. The distance between the horizon and eye level gets bigger as you raise in altitude. Impossible if the Earth is flat. Toon, anything else?
I noticed that. Let's just review. David claimed very specifically that the horizon always rises to eye level. I showed that it doesn't, and then they ran away from that claim and said, "Oh no, refraction, diffraction." Some word salad stuff. So I thank you for retracting your claim there, David. But we definitely did show that the globe prediction matches because they were very specific. I appreciate this. They said the horizon should drop 0, and I showed that it dropped 3.3 degrees. Now, if you want some more measurements, I've got more measurements. It's the same. It matches the globe every time, Flatzoid. So just trying to hand wave, say, "Oh, you didn't replicate it." Well, sorry, it does match every time. So, yeah, thanks for not having that. And I guess if you want to run away from this beating you've gotten, that's I guess that's fine.
I mean, we're
just wave that white flag. Go ahead.
We are more than happy to talk about your misunderstanding of gas pressure and how things are. We don't mind. We're not running away from that, but we just know you're running away from this one without answering our questions. But more than happy to move on to gas pressure. Please, over to you. Give us your evidence that gas pressure, whatever, proves that the Earth is flat. Please, I'm excited.
Okay, you guys are up.
Okay, first of all, MCTOON, this is the 4th time I've told you now, relative to eye level. Learn the words, please. Yeah. Okay, and no, you have not replicated at exactly the same altitudes and got exactly the same results. That's just an outright lie. Okay, so yes, the water, before we move on to the gas, the water is physically below your feet, not physically rising. That's why it's called relative to eye level perspective. Everything converges. And I was so hoping you were going to bring up your orthographic trigonometry today. I was so hoping that you didn't. Hey, you would have got stuck on that too. But anyway, let's move on to gas pressure containment. According to gas, it requires containment to have volume. No containment, no volumetric containment for gas. So you can't claim a volume of gas without having containment. This can be cited, shown constantly. The way gas behaves requires containment. Gas existence requires containment. You are unable to demonstrate this to us, so have already lost the argument. Anything to say, Dave?
Yeah, I'm going to go ahead and cite that for us here. That, let's see, here we go. If you can see that there where it says gases do not have a distinct shape or volume until they are contained in a container. Their molecules are spread out and move randomly, and this property allows gases to expand and compress as the gas is pushed into different container sizes and shapes. The volume of gas can be defined as the volume of the containment in which it is contained. When a gas is compressed, its volume decreases as the molecules become more closely packed. All right. Within that even more, I'm going to stop that real quick, and I want to bring up something real fast because I know we're going to go to the pressure gradient where we want to talk about gas being held by gravity. Well, my friends, nothing could be further from the truth, because as you can see, I've already filled this with some gases, and I've got a little heating and cooling thing. Take note of the pressure right here. And what I'm going to do is, as I cool the gas, oh my goodness, look what starts to happen.
The pressure drops.
Starts to happen to the pressure. We start getting a gradient. Now, if we combine this along with Dalton's law, which says that the pressure, the sum pressure, is the combination of each of the individual pressures of each of the various gases in.
Go ahead, Craig.
Yeah, I'm sorry, Toon. I know I've used both our buzzers, but he said something there which didn't happen and moved away from it. So I just want, before he moves on, he said reducing the temperature made a gradient, but it didn't make a gradient.
There's no gradient there.
Could he point out where the gradient is that's caused by reducing the temperature? Please. And again, I apologize for using both our buzzers, but I didn't want him to just skip over that.
You get you get two each.
Gradient, but didn't.
Two each person. So, just so you know.
Dave, could you? Oh, sorry, we've got two each. That's cool. Dave, before you move on, could you show again using this simulation where the gradient is caused by temperature, please? Thank you.
Paying any attention at all, I said the gradient is a temperature gradient which causes the various gases to get lower in pressure as you rise in altitude. I never said this was a pressure gradient. This is merely a demonstration as to what happens with gas pressure when it's heated and cooled. And as the gases are traversing our various temperature gradients in our atmos, they behave in a different manner, along with Dalton's law, as I started to state, the sum pressure being the entire pressure combined of all of the rest of the other gases together. We start losing some elements at some of the higher altitudes as well.
We've explained this many times. He's talking about also the partial pressures. Okay, so where is on his thing where it was going to show it's getting colder, that's where it started moving slower. So what happens with gas is, I don't know if you guys know this, but if the gas moves slower, it gets denser, so it moves slower. It takes up less volume. So when you have different gas behaviors in conjunction with us in a dynamic system, the bigger the volume of the container, the more gas you're going to require, or the more energy of that gas to move freely to expand. Example of this, you can go to a bottom of the ocean and you can just pump a little bit of gas like this in a big tire or something and let it float up. And when it gets to the surface, that tire is totally fully blown up because gas expands. This is why we say we have gas behavior. Notice that all our demonstrations require containment. The burden's on you to provide us where it does not need containment to hold this gas to Earth adjacent to the space vacuum you call globe.
Or at the very least, demonstrate air having a downward acceleration due to gravity.
Indefinitely, by the way.
Yes.
Yeah, go ahead.
Passing? Yeah. Okay, go ahead, Toon and FTFE.
All right, I'm sharing my screen, Jared.
You can do that. Go ahead.
All right. So, well, David very clearly did claim that it created a temperature, some sort of a gradient in that container, but never showed it. Whatever that gradient was that he claimed, he never showed it. It didn't. But anyway, he did also very, very specifically claim that the temperature causes the gradient. And here's a graph comparing the temperature in the air to the pressure in the air. And you can see that wavy line back and forth is the temperature. And on the right side of that graph is the pressure going from regular at sea level to a short, a little bit above Mount Everest to basically zero. So I will ask then for, why is it that you think that it does that when it clearly doesn't? Go ahead, David.
Okay, I don't know what happened to Dave.
Okay, anyway, simple. The reason we can see this happening, Mike, is because we have dynamic gas system. This is exactly what you were talking about. It's not just based on temperature, it's based on volume. It's based on the temperature, based on pressure itself. Avogadro's law, the amount of gas, the higher you go up, the less amount of gas there is, the larger volume it is to fill. And it has temperatures to attend with. So that's why we have pressure gradients. Notice you still haven't shown us gas pressure out containment. You have moved on to pressure gradients without showing us the containment for that pressure gradient. He asked you a very specific thing. Demonstrate us gas being pulled down indefinitely by gravity without the need for containment. Not tell us to explain how pressure gradients work. You're just trying to run down our time. I yield.
Dave?
I just want to congratulate Mike on completely misrepresenting everything that I said in my demonstration.
Mm-hmm.
I yield.
Passing? Okay, go ahead.
If it's based on volume, the volume's constant. So I'm just going to show my screen.
Are you not aware that the volume is constant, Flatzoid? You're laughing. It seems to me that you're confused that the volume isn't changing.
Right. So, wrong one. 2 secs. Here we go. Right, Jaren, is this showing?
Yes.
Right. So, here is a gas pressure simulation similar to the one that Dave was showing. Right. I'm going to pump this up and put a bit of gas in there, and yeah, we see how it expands equally in all directions. As that's exactly what Dave said. And let's remove the heat. And what that does is it slows everything down a bit, right? However, there's no gradient in here. But if we turn on the gravity, we then get a gradient. And by a gradient, we mean at the bottom here, there is more of the pressure, and at the top, there is less of the pressure. This is the gradient, and that gradient doesn't exist without the gravity. Changing the temperature doesn't make a gradient. But
this matches observations where their claims don't match observations.
Yeah. So, but here's another thing. According to this simulation, if we just take off that lid, some of them are getting out. But if we turn
there's no containment anymore.
Look,
what happened?
But it's still staying in there too.
Something is containing it.
Yeah. So this matches observations. This matches what we see in reality, because
Yes.
if we look at the atmosphere, we have more at the bottom and then less as we go up, and then we can see physically.
And there's no lid, just like on the globe. There's no lid.
Like
that
in the
totally
picture,
matches observations.
yeah, the literal
Amazing.
picture, Dave, doesn't have a lid on and matches this match what Dave has put up.
So now,
Because
they probably will strawman the globe again, but
yeah,
it's
yes, but
expected. Okay.
just to reiterate my point, gravity equals gradient. No gravity. Oh,
No gradient.
Oh, damn it. Oh, guess gravity's kind of needed for something there.
Yeah,
anyway, yeah,
yeah.
yeah, please.
Passing?
Yep.
Go ahead.
Go ahead. Go ahead.
Wait. Okay, I have to put this. Can you please put that back on screen for us and show us what lots of gravity is again?
You asking him? I'll bring him up.
Yeah, they're putting on screen quickly.
No gravity, but lots of
What is
gravity.
that? What's that? Lots. What is lots of gravity? Can you explain to us what lots of gravity is?
Yeah, I'm wondering about that.
That would be a larger acceleration towards the surface.
What's the measurement of that lots of gravity, please?
It doesn't actually give the measurements.
You know why? You know why? Because it's not demonstrable in reality. Would you say that's Earth's gravity?
This is what we see in reality, though. This matches.
No, we don't. You have
Yes,
yet to demonstrate gas pressure without containment. You go to a simulation, it says lots of gravity. It's not even giving the correct amount of gravity you need. Can you please put us the correct amount of gravity if you're claiming this to be gravity, please? Put the correct amount of gravity in for us.
Passing? Go ahead. You guys are up.
Yeah.
There we go.
Fine.
That is what the correct amount of gravity. Lots would be 1G.
What?
There we go.
There you go.
Sweet. You.
That's the answer? Okay. Go ahead, Flatzoid.
Okay. Okay. Provide a citation that lots of gravity is 1G. Go ahead.
Yeah, I'd like to know a gas law that uses gravity.
Doesn't. And I'm waiting for Craig to bring up that citation used against me last time so we can read it together, where it literally says this is not based in real world.
Passing?
So, yeah, go ahead. Because
well, outside of a cartoon, though, can you actually demonstrate? I mean, we know what happens to gases with temperature, but can you actually demonstrate air having a downward acceleration due to gravity?
And note, they still haven't actually answered us. Without containment, you're moving to pressure gradient again, which is a byproduct of containment. So actual demonstration for us would be great. Thanks. Without using lots of gravity that doesn't exist. Yeah.
Okay. Go ahead, Toon. FTFE.
All right. So Flatzoid, you keep saying that this is some sort of a law of nature of a containment. So could you give a citation where it's a law of nature, please?
Passing? Okay. Go ahead, Flatzoid.
Entropy, the second law of thermodynamics. That's a law of nature, is it not? And Avogadro's law, Gay-Lussac's law, Boyle's law, Dalton's law, every gas law in existence means volume. A volume means containment. So, yeah, in nature, every single demonstration, observation, we require containment. You have yet to provide us a demonstration of reality or anything other than trying, let's move to pressure gradients with lots of gravity that doesn't exist.
Again, the citation that you're asking for, gases do not have a distinct shape or volume until they are contained in a container. If you wish, I can put this in the chat for you as well.
Passing?
Yeah.
Okay, go ahead. FTFE.
It is very, very simple. The atmosphere has a gradient. We are talking about the atmosphere, not just gas in general. So if we want to compare something to reality, the reality is the atmosphere. The atmosphere is showing gas pressure without containment, because as the picture behind Dave shows, there's no container. Back to you.
Oh, let me just, if I could, Craig, quick. Flatzoid cited the second law of thermodynamics. The second law of thermodynamics states that the state of entropy of the entire universe as an isolated system will always increase over time. That doesn't, first of all, it doesn't talk about gas pressure. Second, it speaks about the entire universe, not about some small system. So it doesn't apply to the circumstances that we're talking about. So
yeah.
Could you find and then all the other laws that you talked about, bring them up. Now, David, your particular citation talks about the shape of gas. That's what we're talking about. You're asking for a citation about it requires containment or an example, right? And I'm just asking, where is that? Where is that requirement in science, that citation? I still haven't seen it because the second law doesn't do it.
Passing anything, Craig?
No, I mean, I would just really like them to answer the questions that were asked about, how it is. Reality is that there is a pressure gradient without a container. That is what happens in reality. If they're claiming there is a container, simple thing to ask is, can you show us the container? Because the picture behind Dave shows gas pressure.
There's no container. But there's no container there, obviously.
Exactly. Gas pressure without a container. Picture behind Dave is literally showing that. So, if we're talking about the atmosphere, that is what we're going to refer to. That is our example. And it matches the simulation with gravity turned up all the way. Back to you guys.
Go ahead.
Hey. Okay. Anyway, MCTOON, thanks for showing once again you're ignorant to thermodynamics and you should not be talking about it. This is Libertex chemistry, entropy and the second law of thermodynamics. Let's go down a bit. What's it talking about? Gas in containment, temperature of a gas surrounds are equal in a container. Do you know what volume 1 and volume 2 represent? Do you know how, let's put it this way, do you know anything about entropy and gas laws, to be honest? Secondly, when you guys claim again gas behavior, aka gradients, it's explained with all gas laws. Also, I can move on to another screen where Craig was also shown to be ignorant when he says the atmosphere is not the same. Is it showing the screen? The atmosphere is a mixture of gases. This is why we bring up Dalton's law. Okay? You guys need an education on what gas is? Let us know. Again, no containment, no argument.
Flatzoid, can you pause?
I would like to I would like to add to that too. Again, misrepresenting what I said. If we need to look at it again, which I'm sure we don't, most of the other people that read it are smart enough to realize that it said gases do not have a distinct shape or volume until they are contained in a container. Or volume, you understand? That was also there. There's this conjunction called or that was used, and you negated to point that out. Okay. And secondly, if Atmos is a combination of gases, reproduce that combination of gases in a volume without a container.
Yeah, and notice that they said, oh, behind you, we can't see the container. Okay, I don't see a cow when I eat my steak. Does that mean the cow doesn't exist for the steak? It's the same thing.
To pause the clock real quick, Flatzoid, I did not show people what you just put on the screen last.
Did you? Oh,
I didn't.
Which one? The second point or the?
Yeah, just whatever you did last. It was quick, and I didn't get it.
Oh no, that's fine. I was just showing on screen that the atmosphere is comprised of gas. Okay. That's all. It's just so they can know atmosphere is gas.
Got you. All right, you guys, Craig and Mike, go ahead.
Sorry, they I think they missed the question there. I just asked them to show me where the container is in the picture behind Dave there. Yeah, if you see it,
but now I want some steak. Anyway, go on.
If you see the cow, you can see if you see a picture of the cow, then the cow's there. But there is literally a picture of gas pressure with no container. So
right behind Dave.
Yeah, right behind Dave. So
that's amazing. Thanks, Dave.
Just quickly. Back to you guys. Please show us where this container is in that picture behind Dave.
Go ahead. Oops, sorry. Now you're...
Okay, you're reversing the burden of proof again. Behind him is a picture of high altitude. Notice that the light scattering makes it dark. This means you can't see. What happens when you put the light off in a room? Can you see the wall? No, but that's a different argument. So instead of trying to reverse the burden on us, we don't see containment. Be a big man, pull up the socks, and show us a demonstration of gas pressure without containment. That's all we ask, just a demonstration.
Good, pass, go ahead.
The atmosphere is a demonstration. Please, once again, show me the containment in the picture behind you. Claiming it's invisible doesn't work. You say there's a container, show us the container. Back to you.
I'm not going to do that again. Keep going. You already asked that.
No, that's my point. Oh. That's my response. I don't have anything else. He's making a positive claim there is a container. Show me the container. End of story.
Try it again. Go ahead. It's going to be the same thing again.
Okay, all gas laws in existence, natural law, all observations dictate containment needed for gas pressure. So you want to see where's the container? The fact we're breathing is the evidence we have containment. Thank you.
The only way for a gas to have a pressure is to be in a contained volume. This puts it in a state of disequilibrium. This is what causes the pressure in the first place. If you increase the size of the container, the gas pressure goes down. If you increase it, it's going to go up. It's the same amount of gas. So it doesn't have, once again, a distinct shape or volume. This is why I use the term atmos, because gases don't have a shape, okay? Other than to take the shape of the container that they're in. And also, Toon, I've been meaning to talk to you about that fucking column of air you left here in my house.
But also note that when McToon said, yeah, the containment is constant, I was like, yeah, you debunked yourself. Well done. Containment, constant. Yes, the container is constant. The behavior of the gases is not constant. If there is 10 molecules in a larger space to fill, it's less pressure than the 10 molecules in a smaller space to fill.
So there's no downward acceleration of air. The pressure that we feel, the 14.7 psi approximately, that's an average that goes up in millibars up and down all day long, is nothing more than displacement. That's why it's the displacement per square inch on whatever is displacing the medium. That's all it is. It's not a downward push of air. That's dumb. You'd be able to show
demonstrate.
That.
Can we just ask them? Yeah, they're trying to run our time down. So just demonstrate us gas pressure without containment, please, guys. That's all we ask. Just demonstrate.
Okay, go ahead.
To be clear, you were strawmanning us. We don't claim a volume for the air on the Earth. We don't claim a specific shape. It's amorphous around the Earth. So that's the straw man. And again, I really want to see, and you didn't bring it up. You said second law of thermodynamics. I showed you in the citation there. It does not apply to the circumstances you're talking about. So, and then you say all the other gas laws. So could you show me where it states very specifically in these other gas laws that it requires that container? So show where it states that in the gas laws, please.
Yeah. Specifically in the gas laws. Yeah.
Yeah.
Okay, go.
Joule's free expansion of gas.
Avogadro's law, Boyle's law, Gay-Lussac's law. Which you want to go on? The second law of thermodynamics and kinetic energy of gases. How about a studysmart.com, entropy change of ideal gas. The amount of gas increases, the entropy will also increase. Change in volume. If the final volume is greater than the initial volume, the entropy change is positive. The ideal gas constant, that'd be Boltzmann. The gas constant is proportionally constant to the ideal gas law and influences of entropy change. Notice, guys, your atmospheric pressure is based on ideal gas law. So you can't say, oh, why are you reading ideal gas law? It literally is based on ideal gas law. So yeah, we move on to you guys again to flounder and show us how you do not show us gas pressure without containment, and want to move to us to educate you on how gas is affected by entropy.
Okay, you guys are up. And remember to get your super chat questions in if you have questions for the guys. Go ahead.
Don't know about you, Toon, but I didn't see in any of those citations where it says a container is required. So
I didn't. No, all they did was they named off some gas laws, but never in them did they actually bring up on screen and show the citation saying that that gas requires a physical container. None of them said that. So they keep saying this, making this claim, but refuse to actually support their claim. Wave that white flag, guys.
Yeah.
Passing?
Yeah.
Okay, go ahead. You guys are up.
In closed containers, answer, gases diffuse, meaning they move from the area of high concentration to the area of low concentration. When gas jar is not sealed, the gas inside will diffuse into the atmosphere. To keep the gas from escaping, the container must be thoroughly sealed. Brainly in.
And once again, in order to have a volume of gas, Mike, just like we said before, it must be contained. Otherwise, due to Joule's-free expansion of gas molecules, it will disperse and there will be no pressure.
Yeah. Just the definition of volume alone debunks them. Again, another one from bias.com. The intermolecular space between the molecules is quite large, so the particles of gas constantly move with high kinetic energy, and hence they occupy all the space in the container which they are placed. Notice we haven't found one thing where it says no containment for gases yet. So again, we yield our time so they can waste their time while they show us gas pressure without containment.
Okay, go ahead. Toon.
You strawman again. We don't claim a specific volume. So could you show these things where, since we don't claim a specific volume, every time you talk about that, you're not talking about our claims. You're talking about something. Well, you're talking about your claims because you must claim a specific volume, right? You think the whole pizza pie dirt pizza is contained inside a fixed volume. Show the application of those volumes. Go ahead.
Yeah, but first, before we go back to them, I do want to just, so they don't accuse us of just running away and not answering their question. They want to see gas pressure without containment. Then I'm going to show them a picture of that right now, but they're instantly just going to claim that it's fake. All right, are we all ready? It's already up. It's already on my channel, but here it is for all you guys on Jeranism. There is a picture of gas pressure without containment. Can you just confirm, Toon, that there is no container there?
There's no container there.
And can you also confirm that there would be gas pressure there?
What are you showing? You mean
there's gas pressure? I've been there. Yeah.
Somebody's sharing their screen. Just so you know.
No, Flats is sharing his screen.
So it's sharing his screen whilst we're talking.
My goodness, he's trying to cheat.
That's a nice way of doing it. It's pretty good.
Put your nose on the wall.
We should definitely get some time back there. But yeah, so there is a picture of gas pressure without containment. And 3, 2, 1, prepare that's fake.
Can I also say Jupiter? You can see Jupiter through a Nikon P1000. I've gotten it myself, and that is a gas pressure next to space without a physical container. So there you go. A couple good examples.
Yeah, and just to point out that the things that they showed weren't gas laws; they were just things on Google. We're still waiting for a gas law that says containment is required. Yeah. But back to you guys.
All right.
Go ahead, Flatzoid.
Okay, first of all, we have to tell you, we never said picture. I have a picture of Bigfoot, or I have a picture of a fairy. That doesn't make fairies or Bigfoot real. You haven't yet shown us a demonstration. Do you know what demonstration is? And by the way, Michael, when you say you don't claim a volume, what is Dalton's law when we brought up Dalton's law? That is volume, you Burke. The volume. The dry air in Earth's atmosphere is about 78.08% nitrogen. That's a volume. 20.95% oxygen. That's a volume. And 0.93% argon. That's a volume. Yes, and I will talk that way because I have to educate you on your own globe model. So please demonstrate, not make a picture of fairy in Narnia. Demonstrate gas pressure without containment. While you do that, I will quickly get you all the gas laws and show how all the gas laws require containment.
right? So as you still didn't pay attention to what I'd said before, any volume of gas requires containment. Otherwise, it won't be in a volume. That's just the nature. That's how gases work, man. You didn't listen. I said that now 4 fucking times.
Passing?
Yeah.
Okay.
This one out while they get the demonstration.
Toon, you got 2 buzzers left, and Saab, you have 1. Everybody else 0.
Yeah,
So,
Flatzoid. Just Craig, I just.
Yeah.
Flatzoid thinks that a percentage is a measurement of volume. Let's just let that sink in for a second. He actually put it up on screen and then tried to talk down to us as if we were the children, but he was the child, claiming that a percentage is a unit of volume.
If anyone watching on, just please clip that for me.
That's amazing. That's amazing. Do it again, Flats. I want to get it on record again.
Yeah. And it's also nice to see how they're asking us for a demonstration of this thing, but we've
given it. Yeah.
A picture of the demonstration.
Now, what is a demonstration? How about they could define what a demonstration they would accept is? Because they won't take pictures. So whatever's behind David, they won't accept. Right? That's not evidence according to them.
Is a live video from space evidence? Is looking outside?
It's just a sequence of photos. That couldn't count either.
No. What do they want me to literally do something in my room right now, which would be
that would only get received to them via a series of photos. So again, it's not acceptable according to their standard of evidence. So I don't know what their standard of evidence is. Maybe they need to define that so that we can be sure to match it. And of course, hold them to their own standard in the future.
Yeah, and basically, if they're going to dismiss a picture that I put up, then I immediately also dismiss any videos or pictures that they put up.
Yeah.
Because we have to work by the same standards, right?
Of course.
So I'm just going to work with this right now. I am going to, once again, just show this picture, and I'll put it...
Flat, stop sharing during our presentation time.
Sharing? Well, yeah, right.
Come on. Put your nose on the wall, Flatzoid. I told you last time. Nose on the wall.
It's literally trying to cheat. Right, I'm just going to once again quickly put up.
He's not doing it. David, you need to get Flats to put his nose on the wall.
So
naughty boy.
This, I don't care if they say this isn't. I want them to point out to me here in this picture that was taken with a physical camera and then developed in a dark room.
Flats, I love you, man.
Still available. I want them to tell me where in this picture the container is. No obfuscation, no talking about gas laws or anything, just simple. Stick with this right now. Where's the container in this picture of gas pressure?
That's so funny.
Are you guys passing? Okay.
Yeah, Toon, unless you've got anything else.
No, I'm good.
Go ahead, Flatzoid.
Okay. Okay, by the way, first time I shared screen was before you shared screen because you asked me to get something up. Second time again, I said I'm going to get something up, so maybe pay attention. Gas laws, volume. These are all the gas laws that there are, guys. Every single one. What do you think that V stands for, guys? What does V stand for? Volume. What is volume by definition? Let's quickly go there. Is it going to show this screen as well?
Yeah, we see everything.
Is it showing it?
Yep, we see it.
Okay. Volume. What is volume, guys? Or in that enclosed with a container. So it's the amount of space that the substance, physical substance, in this case gas, or object occupies in that enclosed container. Then I got another one. Dalton's law. I think that's showing now as well. Yep. It's the partial pressures that state the partial pressure of the ideal gas in a mixture of ideal gas is equal to the pressure gas I would exert if the alone occupied volume of the mixture at the temperature of the mixture. In other words, Dalton's law is literally volumes, percentage of volumes of a gas in a large container volume. MCTOON and Mr. FTFE. Again, you know, I can take a photo in a darkroom of a model and get it placed because it's film and say, look, I went to space. Doesn't mean I went to space. It just means I took a photo in a studio. Thank you.
Using the very thing in question as your demonstration of the impossibility of which we claim would be an impossibility is beyond ridiculous. So here is the standard: repeatable and demonstrable scientific experimentation that would allow you to show gravity causing a downward acceleration of air, or a volume of air collected together without a container. We, of course, know that these things are impossible. This is why you have to say, oh, it's too big. Well, I say that's what she said. Anything else?
No, that's about it, because they have yet to demonstrate to us
Can't demonstrate
pressure containment.
Oh.
Okay, Craig.
Yeah.
Nowhere. Yeah. Go ahead.
Allowed to use the thing we're talking about as an example, because to ask us to show you air accelerating downwards with gravity on Earth separately in a lab is a straw man of the position we hold. So if you want to straw man, that's fine, but we don't need to respond to a straw man. Our position, and let's be very clear about this, our position is that gravity is keeping the atmosphere on Earth and creates the gradient. Gravity is empirically verified. You are strawmanning our position. That is as simple as that. We do not claim there is gas pressure without containment. We claim there is a gradient created by gravity. So,
and that pressure is positive everywhere. Very clearly, pressure is always positive everywhere. So there is no area of no pressure that exists. Is he sharing again over us?
No.
Again. And he's what kind of softcore stuff are you looking at here, Flatzoid?
Nobody's watching that. Nobody sees that.
What?
It's not on the screen, so don't worry about it.
It's all right. Well, I'll get us. That's fine. That's fine. Thanks, Flatzoid. I got a screenshot of what you're looking at. I'll play it later for people.
Yeah, none of those are picked. They're
doing.
But if you are making the positive claim that a picture is fake, then you have to, verify that positive claim, because let's be clear, that is fake is a positive claim. And let's be clear that it has been repeated. There is many pictures of Earth from space. It is something that is repeated all of the time. And you just going, oh, we're not going to accept that picture, is just trying to avoid the fact that here's the evidence. Here's a picture taken from space. The picture behind Dave shows gas pressure without containment. And you can stop sharing your screen, which is, again, you're just trying to use our time. Jaren, would you mind stopping and sharing the screen? Thank you. Yeah. So, again, you can't just dismiss the evidence that we're saying is there. The atmosphere has a gradient in it. It is created by gravity. There is no container in the atmosphere. If you are claiming the positive claim that there is a container, then you have to give evidence of that, not just assume it's there. You're literally affirming the consequent. Gas pressure requires a container, therefore container. That is literally affirming the consequent.
Yeah, it's all backwards. Yeah.
Yeah, physically.
Well,
show the container.
I want to really make it clear. All of those specific gas laws that he's talking about don't apply because they have the requirement of a fixed amount of volume, which isn't what we're talking about. We don't claim a fixed amount of volume. So when he cites these gas laws, it doesn't apply. So again, it's just the affirming the consequent that they do over and over and over, claiming that that is somehow a requirement, but never actually being able to show how it's a requirement. Maybe you have an experiment showing that that's a requirement. I don't know, but you keep going around in circles, not being able to show the requirement.
Yeah, the fact is, we have a pressure gradient. We've taken pictures from space. No container has ever been seen. If you're making the 100% positive claim, there is a container for our atmosphere, just show it. Over to you.
Go ahead, Saab.
So that was a nice reversal on your part. However, you still have not been able to demonstrate a downward force of air at all. You can't demonstrate that at all. And if the air is actually being pulled to the earth due to gravity, you should be able to show demonstrably that there is a downward force on air. And you cannot do that because the PSI that we experience is actually a result of displacement. And once again, any volume of gas, Mike, any volume of gas requires containment. So it doesn't require a specificity on it. Okay? Yeah. Any volume of gas. And until you can demonstrate otherwise, this natural immutable law stands. Sorry.
Okay. Yeah, so I'm sharing my screen again so everybody can see what I was sharing. Guys, this is a screen share of fairies. Now, this is pictures of fairies. Is the fairies real, guys? Are the fairies real? Yeah, because I take pictures. Guess what? Craig's argument. We've repeated it. We've taken multiple different pictures of fairies. So therefore, fairies are true, guys, because we've taken multiple pictures of fairies. Yeah. That's not how it works, dude. I can take multiple pictures of Bigfoot too. I can take multiple pictures of pigs.
Go ahead, Toon.
All right. Well, David claimed very, very specifically that this requirement, this containment requirement, is an immutable law of nature. So I'm going to ask once more, where is the citation that gas pressure requires a container is an immutable law of nature?
Okay, go ahead. Stop.
Gas holes.
Yep. So in order to have a gas pressure, you must have a volume. And in order to have a volume, we must have what? Containment. There it is. Sorry, my man.
You literally showed him the citation for this in the beginning. I don't know.
5 times now.
Sorry.
5 times I've cited it. 5 times.
And I cited how many different citations showing him all gas laws and even entropy of gas described. You need a containment because it's volume.
Go ahead.
All right. Once again, all you did is reassert as if it's a religious mantra of yours that it is a requirement. Your citation doesn't say that. It's a requirement. It's just referring to things. It doesn't say that it is a requirement, an immutable law of nature. So go ahead, show the immutable law of nature citation or wave the white flag.
Okay, Saab. By the way,
gases do not have a distinct shape or volume until they are contained in a container. In order to have gas pressure, you must have a volume. In order to have a volume, you must have containment. Until you can demonstrate otherwise, sorry about your luck, bud. You can sit there and scream, citation, citation, all the hell you want to, but you still have not successfully demonstrated your claim of gravity affecting gases.
Yeah, I don't know. Okay, I'll share the screen again for them showing the citation we're talking about. Literally says it here, volume of a gas. Gas is unique state of matter because it doesn't have a fixed shape or volume. Do you understand what that means? It doesn't have its own shape. If you don't have container, it can't take shape. Instead, gas molecules can spread out to fill any container they are put in. This makes it tricky because to measure the volume of gas, notice to measure the volume of gas, where am I? To measure the volume of gas, but we're here to help in this article. We explore the properties of gas volume and how it affects other properties. Plus, we'll give you some examples of how you calculate gas volume because you can't measure gas. Guys, you calculate gas volume because you need a container to do so. Gas does not have any distinct shape or volume until they are contained in a container. There is your citation. MCTOON for the 6th time now. There we go. On to you guys to hand wave dismiss it for the 10th time.
Yeah, let's try and get it on something new. If you just ask the same thing back again, it's getting kind of ridiculous.
All right. Well, let's be clear. The claim that we are making is that there is positive pressure everywhere. So if you're demanding this type of stuff, what you're doing is a straw man. So we say there's pressure here, it's positive. There's pressure at high elevation, it's positive. That's all that we're claiming. We're not claiming that there is a zero pressure area anywhere. The entirety of the universe has a positive pressure. And that goes completely with the second law of thermodynamics, which only applies to the entire universe. But I can show you what we do claim. We do claim a pressure differential without a physical membrane between them. I have right here a barometer app on my phone, and at let me make sure it's on screen here. There you go. You can see it. So right here, pressure is 978 hectopascals, and if I raise it up, 97. That was 979 down low. Now it's at 97. Let me go down here again. Give me a 97. Hold on. 97. There you go. 979 right there. 0.00. And a 978.9 something. So it reduced in air pressure. That is our claim. And so we say gravity causes that. And when you apply thermodynamics, there is with absent a force, there's no reason why there would be a pressure differential. And so if you're going to say there should be a pressure differential, I'm going to need to see the experiment that causes a pressure differential in the absence of gravity.
Yeah, totally. Yeah. So just to clarify, yeah, you guys are right. The gas pressure is contained in the universe. The universe contains all of the gas pressure in the universe. Contains. That means it is a container. The universe is a container, and it contains the gas pressure. The gradient of that gas pressure is created by gravity. Over to you.
Go ahead, Sop.
Okay, so I'm still waiting. I'm still waiting for the demonstrable experimental proof of air having a downward acceleration due to gravity. Any gas having a downward acceleration due to gravity.
Indefinitely.
You don't have it anywhere. There's your problem.
And
so
we're gonna
go ahead, Kate.
Sorry, and we're gonna ask you guys quickly because our time's running out. Do you know the 3 different thermodynamic systems? Earth is claimed to be an open thermodynamic system, and space is claimed to be a separate system, the universe, so isolated. You have the Earth inside this separate system, which means there are 2 different systems. If Earth is an open system, I'm going to see if you guys actually know anything about entropy and gas behavior now with thermodynamics. What is the difference between the 3 thermodynamic systems?
Okay, go ahead, Craig.
Yeah, move over.
All right, well, that was off topic. Anyway, I did show it. I showed absolutely right here, demonstration in real time, the pressure differential due to gravity. And lacking a force, there's no reason why that would happen. So, yeah. and you are, I know you're unable. I know if I ask you, you will wave the white flag and absolutely refuse to support your claim that there is something causing that, right? But what is causing that? You will never provide any supporting evidence for it.
Yeah, so you literally did show him a demonstration of a downward acceleration of air due to... You literally showed...
9.79 here, 9.78 and some change up there. There you go.
Well, yeah, there is the demonstration.
If it's not gravity, then what is the empirical evidence supporting your claim that it's something else?
And just to be clear, thermodynamic systems can exist inside of each other. It doesn't stop the fact that everything within the universe is contained within the universe. Everything. To quote Rick Sanchez, everything is in fucking space. Back to you guys.
Go ahead, Keith.
Yeah, where's your empirical evidence that was caused by gravity there, Mike? That's my question to you. Go ahead.
Notice barometers require containment to work. It's a surface area, Michael. Secondly, yeah, all gas behavior tells you why we have that pressure gradient. Thirdly, notice how they haven't able to answer us the 3 different type of thermodynamics that I specifically asked him to tell us about, showing they are ignorant to the subject and should not be discussing this because they don't even know the 3 different containment systems. And FTFE should know this by now, because my first debate I had with him, I had to school him on the difference between open and closed. Back to you guys.
Yeah, I see he's trying to get us off topic by asking us a question instead of answering the question that we asked. Yeah, I know all about the different the systems. That's fine. Everyone on my channel knows about the systems, but we're not going to let you take us off topic. Toon, please ask the question again.
Well, I gave you an empirical evidence for that. So you're all you have is the right? Well, you need to prove that it's caused by gravity.
Go ahead. Stop.
So you need to prove that it is caused by gravity, MCTOON. Absolutely 100%. You do not have a demonstration. No one has demonstrated, not once. That was not a demonstration of anything other than a barometric change in millibars. Not even that. It's even just fractional. We're in a dynamic system. Notice you have to be able to have a volume of gas in order to have a pressure to measure in the first place. Demonstrate through repeatable and demonstrable experimentation a gas pressure without containment. And please try not to beg the question this time.
Yeah, and like I said, I already answered you. Your barometric pressure is based on Boyle's law, which requires containment. You have a surface area to read that pressure gradient. Pressure gradient comes after containment. It's literally invalidating your argument that this is caused by gravity when you haven't produced evidence that it is contained due to gravity. You haven't shown us anything that shows containment is not required. Again, on the same topic, the three different type of thermodynamic systems, because this is directly in argumentation of why we need containment for gas pressure. So do you know the three systems or don't you? Thank you.
All right. So a barometer doesn't actually contain. It doesn't like have some sort of a thing that it goes and grabs it and then physically closes in on it. It's just it's just a surface area of it. So it's not a container. There's no containment involved in a barometer. I don't know why I think that. Anyway, so I will just simply cite the many measurements of the existence of gravity. You can find them on my website at mctoon.net/G. There's quite a few of them. My personal favorite, if you want to look on there, is where they use 13 tons of mercury to confirm the gravitational pull. So
yeah. So just quickly, Toon, do we claim there is gas pressure without containment? Is that our claim?
No, it's not.
Oh, so is it
strawman? Strawman is the word.
Every time it asks us for an experiment that shows gas pressure without container, is he strawmanning us?
Yeah, their entire argument is based on a strawman. Their whole thing, every single word that they've done on this topic since the beginning is foundational on a strawman.
Yeah, yeah. So like Toon touched on at the start in his minute opening, Richard Feynman says that science requires you to calculate the consequences of a prediction. If we make the prediction that the gas on Earth is accelerated towards the Earth because of gravity and calculate the consequences of that, the consequences of that calculation result in the demonstration that Toon gave.
And they match, yeah.
Those are calculated consequences of the prediction of gravity. And that is the repeatable experiment that shows predictions match.
Yeah, I quick in my head did a computation of the consequences if there is no gravity, and the consequences are that the pressure would be the same. Now they say something is causing it. I just want to hear the specific computation that they went through to get that. Let's have that. Let's hear it.
Yeah, brilliant.
Notice the hand wave dismissal. Again, I asked the three different systems. You have still not answered me. And based on barometric pressure again, let's make my point. Surface area to have pressure. Oh, okay. Now I'm going to explain this very simple terms to you guys again, like I explained to Craig before. Earth, open system. Space, surrounding separate system. All the gas we have would fill that space because nothing to hold the gas in. Gas is an inhomogeneous, ever-moving, non-bonded gas molecule. In other words, it never stops moving. no matter what you do, it's always going to move. It can only change direction with a collision because it has perfect elastic collisions. Okay? Yes. So gas would bounce off the floor, the surface of the Earth, which would be an open system, and bounce into space. Notice you say it's a straw man when literally your Earth model is based on an open system in a vacuum. Even Craig brought up a photo and said, see, there is no containment. See, there's gas pressure. So not straw man, literally you running away from the argument. There you go, Dave.
You can also you can do all kinds of calculations all you want to. You have to have some kind of a demonstration that would actually match those calculations. You've said it goes exactly what's predicted. You've never told us what is predicted or what these downward biases of gases changing at these different elevations would be. When it's simple, it's just nothing more than temperature and the removal of some of the elements such as water vapor and things like that. So I don't even know. You still have not successfully demonstrated a gas pressure without containment. You have to have it in a volume. And as we've stated a million times now, that you cannot have a volume without containment. So in order for there to be pressure, there has to be a volume. In order to be volume, there has to be containment. Sorry.
It's not hard to understand.
You can't answer. There's open, closed, and isolated system. Isolated is only kind of theoretical because, let's face it, I think, who is it? Yeti's got a cooler. It's getting close, but we don't have it. So you can't have it both ways.
Yeah, isolated is a hypothetical because it's no mass or energy leaves between the boundaries. We don't have any of those things. We have close approximations like a flask or something. But yeah, a closed system means only energy passes through the boundaries, no matter, and open means matter and energy pass through the systems. Earth is considered an open system, so therefore it's impossible for Earth to exist thanks to thermodynamic law. Yeah.
Pass.
I guess I move on.
Go ahead.
Could you show us the thermodynamic law that says that it's impossible for gravity to hold gas to Earth, please?
Interesting. Okay, Jaron, I have this one up again.
Okay, go ahead.
So once again, David claimed that it's temperature based, but of course it's not. The ever varying temperature in the vertical stack of the air above the Earth is definitely not related to the pressure. There's no relation. Then, secondly, here we have the computation of the downward acceleration as part of the pressure that is expected at any particular elevation based on gravity, right? So you said, well, where is that? Well, here we have it. So this is the hydrostatic equilibrium pressure that you can compute to predict the pressure at any elevation. So we can do it, and so I'm not asking you to do something that we cannot do. We can apply this, and we can get different. In fact, if you look at U.S. Standard Atmosphere 1976, you can look it up yourself. They use this equation here to build that. And this is what then airplanes use for their barometers for elevation. So. All right. Anyway, so there it is. There is how the globe does that. And so I'm curious again. How is it that what is the method that flat Earth and the gravity doesn't exist predicts the varying amount of pressure? Over to you. Thanks.
Okay. Go ahead.
Gravity used anywhere in that at all?
Notice again. Yeah. Also notice they used volume and pressure with volume. Which literally volume requires containment, and you still haven't demonstrated gas pressure without containment. Our time is almost up, but I think we should just let them talk and ramble. So we'll just let them talk and show us when they can actually demonstrate gas pressure without containment.
Go ahead.
I'll point out quickly how again, Flatzoid did strawman me. Never said space is a vacuum. It's a really low pressure area. But it's very true when I showed the picture, there was no container around Earth. The universe is instead containing all of that pressure, including the low pressure area of space. Space ain't a vacuum.
All right. No, I don't know why they said volume was in it, but volume is not actually involved in here. None of this includes.
But
anyway,
is he there?
I think maybe that little delta Z, maybe he thought that delta was an upside down V. Anyway, gravity is in there. You see that lowercase g? So yeah, gravity is involved in predicting the pressure at any elevation. So I don't know what they're talking about. Both of the things that they tried to hand wave this away with, they were wrong about.
I know,
guys. I almost feel bad for him.
I know.
Anyway, so still, what is the cause of the pressure differential, and how can we confirm that empirically if gravity doesn't exist?
We lost soft. Okay, go ahead.
I just take your pressure of an ideal gas is calculated using the equation P equals nRT, where P is pressure and the number of gas molecules R is the gas constant, Boltzmann's constant, which already debunks your globe. T is the temperature in Kelvin, and V is the volume for the container or system. Did you not just bring hydrostatic pressure up?
Pass?
Yeah. Okay. And then also on screen again, Craig says space is not a vacuum. Outer space is the closest known approximator to a perfect vacuum. And that's all I need to say. You go ahead, Dave.
So let's talk about calculations. There's a whole bunch of people right now in federal prison who their math worked out perfect on paper, but you know what? It didn't reflect reality. And so they were called embezzlers and money launderers and things, because just because something is worked out in a formula in a wishful manner doesn't mean that it actually occurs in real life. So once again, demonstrate gas pressure or gas in a volume without a container. Back to you.
Go ahead, Craig.
They're still asking for that weird.
That's the straw man. They keep everything they do is a straw man. Okay, so
wait. I want to point out what Flatzoid put up was space is the closest known approximation. It never said that space is a vacuum there. So thank you.
Thanks, Flatzoid.
Confirming my point for me. And also the formula that he brought up wasn't the same one that you brought up, was it?
No.
Good job. 2 fails in one. Awesome fail, Zoid.
Thanks you. Anyway, still, I want to know, please do show, show, wave the white flag if you don't have it. Just, bail if you can't actually show how we can determine the downward or the variation in pressure with elevation.
Go ahead. Flatzoid.
Okay, on screen for you, MCTOON and why space is a vacuum. By definition, vacuum is developed by matter. Space is almost an absolute vacuum, not because of suction, but because it's nearly empty. So therefore, space is seen as a vacuum. And I brought up hydrostatic pressure based on gas. You didn't. You brought up hydrostatic pressure based on pressure, which would be liquids as well, MCTOON. Liquids aren't compressible. Ouch. Dishonesty?
Mm-hmm.
Okay,
you'll
each get a minute at the end here for a outro, and then we're going to let them go 2 minutes and 22 seconds to finish us off here. Go ahead, Craig and Toon.
Once again, he brought up something that says it's an almost perfect vacuum.
Yeah, he proved your point again.
Yeah,
and I don't know what we was talking about with incompressible fluids. I was not talking about that at all.
It was.
I was talking about air. It was about air, and just I think because it had the word hydrostatic, he got confused, and he thought that that was it. He thought hydrostatic, therefore water. That must be it. I don't know. It made no sense, but that was great. And I want to make it really, really clear: there is no proposed cause for the variation in pressure that either of them could provide. They said it's temperature. I refuted that it's temperature because the temperature varies.
It's not temperature.
It's all over the place. It's not temperature. What is it? He said it's a dynamic system. What does that mean? How do you apply dynamic system? The thing is, a day from now, I can measure that same vertical difference. It'll be the same. I can put it, you could isolate it from the rest of the air so the dynamic system wouldn't be there. It doesn't matter because it's isolated from the dynamicness of the system, and yet there's still a pressure differential. What is the cause of that pressure differential lacking an actual acceleration downward, lacking gravity? What is it? There's still a big old question mark hanging out above all of their claims. And I do want to say, the constant straw manning of the globe is expected. It's expected that you would do it, but someday flat earthers maybe will say, that's not the right way to do things. Or maybe other flat earthers will say, look, flats and some, that was not the way to do it because all you did was straw man. And your whole point about pressure was based on a straw man, and call them to task on it. I think that would be a mature thing for the rest of your community to do.
Yep. Yeah. Just to clarify, the demonstration is the atmosphere we live in. I don't see any container.
Okay, time.
We can go up as high as we want, and we never see any container. You can ignore the pictures all you like. That is just intellectual dishonesty. And if you don't like the way science works, don't talk.
Right, I think we're done. We're done, Craig.
All right, you got a minute to do an outro. You guys want to go first or second since you won the toss?
We'll let them go first.
Yeah.
Okay, you got. Let's go with you, Sob, first. Oops, sorry, I accidentally hit mute. Let me go back to where I was. Escape. Okay, unmute. There we go. So everybody should be unmuted. I'm going to mute everybody. Sob, you got a minute. Whenever you're ready, I will start the clock.
Okay, so we saw no demonstrable evidence or proof of a downward acceleration of air. We saw no demonstration of a volume of gas without containment. We saw no evidence of a gas pressure, of course, without containment, because you have to have a volume of gas in order to have a pressure, which requires containment. It was just a constant reversal of the burden of proof and postulating scientific impossibilities. And that's all I've got to say on it.
Okay, you got a minute. Whenever you're ready, Keith, go ahead.
Okay, it's very simple, guys. From the beginning till the end, all they could say was straw man, when I literally bring up on screen what their globe claims. Failed to show us how the curve is physical. Failed to show us how, with altitude, it does not rise relative to eye level, the horizon, and failed to show us gas pressure without containment. They had shown us ignorance to the subject, though, because they don't know the three thermodynamic systems. He doesn't even know the difference between a hydrostatic pressure of a liquid or a gas, because I can show him citation on that now if we had more time. And also, if it's a straw man, then how am I able to bring up citation that your globe claims those things? It's not a straw man. It's you hand wave dismissing it because you have been shown to be total ignorant to the subject. No gas no container, no gas pressure, no physical curve. Today, the globe has been thoroughly shown to be a faith-based religion. Thank you.
Okay, we've got Craig or Toon, whoever wants to go first. Who's going? Sorry. Unmute you both. Are you muting yourself?
Yeah, I'm.
Okay, you're good. And go ahead.
I'll go.
Yeah.
All right, I'll go first. Again, they reiterated their straw man. Awesome. Thanks for that. And Flatzoid, I don't know what you're talking about. I showed you an actual measurement of the horizon not rising to eye level. So you said that I couldn't do it, but I have already done it. So the personal incredulity. I got the card right here for you. The personal incredulity about that and the just basic denialism is a bit sad, but I'm used to it. It's what we see all the time from you guys. Anyway, thank you, Jaron, very much for having this. Thank you to the live chat. And let me say, in Jaron's chat, you get out your wallets there and get those super chats going. Jaron works hard to do this, and I really appreciate what he does. So I'll be here for the super chats as long as you guys are asking.
Okay, thank you. We can stop the clocks. Thank you, Caprice, for running the clocks. I don't know where Dave went.
I get a minute?
Oh, yeah, sorry.
Yeah, Craig gets a go.
Craig,
no, you don't want to me.
I don't know. We forgot about you. My bad. Okay, go ahead.
Yeah, the constant straw manning is all they've got. It is a straw man of the globe if you say that we need gas pressure with a container. That's not our claim. It's simple. Our claim is gravity makes a pressure gradient. That's it. To say anything else is a straw man. And you just looking at bits and cherry picking stuff will never change how physics actually works. We did give you the demonstration we asked for. It doesn't care. I don't care if you don't like it. I don't care if you ignore pictures. It's intellectual dishonesty. That's all it is. If you dismiss the picture I show you, any picture you ever show, I will now instantly dismiss. But yeah, thank you, Jaren, for having me on. This is, I always actually enjoy coming here. You're actually decent at moderating and running it and stuff. And people on Jaren's channel, get your super chats out and ask us any questions that you want. Come on, Flurfs, bring it.
Okay, and I just have a question for myself because it would be helpful. So if you call something fake, that's a positive claim. So if I were to say to you that, you know, oh, this memory card has 4,000 terabytes, and you were to say, no, that's fake, then it's on you to prove that this does not have. I'm confused with that. I mean, I get that the claim, you know, you can't prove a negative is itself fallacious, because if you could prove that, then you just disproved the statement. So explain to me how we should treat that.
But the claim something is fake, it is in itself a positive claim. Like if someone says they faked the moon landings,
right?
That's a positive claim that requires evidence to back it up.
Yeah. Now, to be fair, I think we need to be fair. To just give a photograph and say this is a photograph, and then say you have to prove that it's fake. That's a bit of a high bar to expect in a debate like this.
Yeah, I would think so.
Right. It's not a game of gotchas. You know, gotchas don't change the shape of the earth. So if somebody puts up a picture of a fairy, then says this is real, well, you'd need some additional substantiation to that. You'd wonder, well, what photograph, you know, what camera was it taken with, who took it, or, you know, what were the circumstances of the photograph? Those types of things would be fair to expect. Once provided, then to continue to say, well, that's definitely fake, would be, well, let me give you the whole photograph, and you know, on your own time, go look at it. In a debate, it's
tough.
You can't do the gotchas. It doesn't work.
All right, let's go to the super chats over here on the YouTube, and thank you guys for sending those in. Let's see what we got. We've got Taking Back Eden, $2 says, Multiverse has a MCTOON, FE, and FTGE. You'd be great. Okay.
In the multiverse.
In the multiverse.
Yeah, I mean, if we are to go with the Copenhagen interpretation of quantum physics, then there is a universe where both me and Toon are fighting for the flat Earth, because every possible circumstance could exist.
I don't know. That's not possible. That sounds not possible to me.
To quote Sheldon, the multiverse does imply this, that, you know, there is a universe where I'm dancing, but I can guarantee there's no universe where I'm dancing.
Okay, V. Lee, $2 says, MCTOON, why don't we measure buildings tilting away?
I love this one. So you say you look at a building that's 30 miles away. It's less than 1/2 of a degree tipped away, but you're looking at it over 30 miles away. So it's pretty difficult to visually see a 1/2 degree tip when it's tipping away from you, right? So here's a cube, and when it's tipped a little bit or not, you can't really tell. That's not enough. So you'd need to have a significant amount of tip, but you can't see that far to see that much tip.
I got plenty of tip.
Yeah, faith-based.
All right, FTFE, you'd make an epic flat earther, MCTOON also. Thank you for $2 from Taking Back Eden. We've got the final experiment, $5. Are Jaren, Flatzoid, MCTOON, and Craig excited for us to finally reveal tonight what the final experiment is? I'll go first.
Oh, that's coming up.
I'll go first.
Oh,
so far, you've said that it's going to take place in Antarctica, so I think it's going to be hilarious as you attempt to get us to Antarctica and prove what we've been saying the whole time, that you can't go there. So let's see what happens, how you're going to get us there. Who's going to do the $1 million EPA study? I guess we'll find out. Maybe that will come out tonight on the last final experiment coming soon. You guys, go ahead. Are you excited, Craig?
Yeah, I'm absolutely ecstatic. I've been talking with Neil deGrasse Tyson about it on the secret NASA moon base. Because he's cousins with the director of the project, and yeah, going to be live. Oh shit! Sorry, my bad.
We know
we got to wipe everybody's memory. Great.
NASA doesn't allow black people on the moon. You know that. Come on, Mike.
Oh, Jared.
NASA doesn't allow it. Have they ever had one? Who's the black person that's been on the moon?
Shame on you, Jared.
Name the black person that's been on the moon.
They left him up there, Jared. That's the guy with the
He
camera.
was the cameraman. Come on.
Up. He's like, yo, you got my ass.
So, all right.
Go, Craig.
About Space Force. And they go
Oh, Craig, what are you talking about?
Mike, we're trying
to... It was the 60s. It was the 60s. They thought he was in the back of the capsule. Yeah.
Don't worry, Michael Jordan's the next astronaut.
Mike, go ahead.
All right. So I did a video a week and a half ago saying whatever it is, I'm in. However, I can participate. So I will stand up and say whatever I'm able to do, I'm in completely, because I'm all for experimentation. So if it's in Antarctica, I don't know if I can go to Antarctica. Probably not. But if there's somebody going to be there, I'd love to see it. I want to see them. I'm going to support that. So.
Looking
and
forward.
Flatzoid, you got an invite too, didn't you?
Are you excited about it?
Yeah, very excited because
you're the closest.
Like you said, we're finally going to show that it's a rigmarole to get there, and you're not going to be able to explore freely like you think you can.
Or maybe me and you'll just be there, and we'll just be waltzing around. We'll go wherever we want. Dave, you
I
come with us?
talking with the penguins.
I think we should have all-out war on the penguins. Just straight up, man. Just fucking take them out once and for all.
Got machine guns. Don't pick on the penguins.
Dude, my dog is named Penguin. Be careful.
I'm talking about...
Right, I'll tell you what.
Except for Michael's dog, I'm saying we should nuke the penguins, man.
Right, if you think the penguins, do me a favor, everyone right now, just Google an up-close picture of penguin teeth, and you will never think...
I got one. You're frightening. It's frightening.
Worse than a possum?
Yeah.
Oh, wow. I don't know about that.
Oh, yeah, opossum teeth are...
They are disgusting. They're crazy animals. All right, let's see here. We've got... Yes, so we're all very excited. No longer on the ball. $5 says, never see bottom of a plane while going over the curve. Can't believe you went with bottom up argument. That takes balls to argue the debunked. Any comment on that?
You never see.
Yeah, you wouldn't expect to see that. That's another straw man of the globe. So.
Yeah, but I do generally see the bottom of a plane when I look up, though. So I'm not sure.
Yeah, no, he's saying when you go when they go over the curve, when they get far enough, but you don't see a plane when it's far enough away to be obstructed by the horizon anyway, and they're not far enough away that it's pointing down. Do this when a plane is 35,000 feet up. How far away is the horizon? A certain number of miles. Now take that, divide by 69, and that's the amount of tip that you'd expect. It's not much.
Okay, we've got Earth is Life. $5 says, Dave and Flatzoid, if the Earth was curved, would we see bottom-up obstruction over water?
Physical, but we don't see physical. It's always optical.
It's an optical effect.
How do you see physical?
As I pointed out,
how do you see physical?
If you increase your field of view, because after the horizon, after the ground stops rising to your eye, relative to your eye level, then you're just looking straight out. You can almost orthographically view it as a slant upward to just below eye level and then carries straight on. And of course, your field of view being obstructed by that actual horizon, by that horizon line. You have full top down to the horizon, but in front of it, in the foreground, that's why the ground, it seems to rise up. But then once it gets to that eye level relativity, you're looking straight out across a flat surface, and it's obstructing your field of view. So if something gets smaller going away from you, your field of view being obstructed more and more by the horizon itself, it's going to appear to lose angular size from the bottom up. It's actually equal, because if you increase your altitude, you'll not only see the entire object, you can increase your altitude and see the horizon beyond it.
Yeah, the largest angle is always going to be the surface.
What you just said was one of the most insanely idiotic things I've ever heard. Not once during your incoherent response.
What a rebuttal.
Resembling a rational thought. Everyone watching this stream,
I'm only responsible for what I say, not for what you don't understand, Craig.
Earth is Life. $10 says, the measurement we're looking for is you all showing a high altitude shot using a theodolite app or a tool that shows eye level where the horizon is not dropped from the crosshairs. Okay, that's
the whole point. It always changes because it's optical.
Okay, we've got Taking Back Eden says, thank you for accepting the truth, Jaren, some flats. Okay, thank you, $2. Earth is Life, back again, $5, says, this container you speak of, is it a solid container? Wouldn't it have to be solid to be able to hold gas pressure?
It's containment. Obviously solid enough to hold it in. No one says if it's a liquid or a solid.
Physical.
Whatever, physical, but it's physically there, containing.
Okay. We've got FTFE and MCTOON. Thank you for being the only ones that are educated to know what you're talking about. That's from 3Ron, $5. Taking Back Eden, $2 says, Craig, please reconsider Jesus. He heals, saves. Thank you.
No.
Oh, okay.
Frankly, sorry.
Clit Rubs, $5. Thank you very much for that, and enjoy your name. If the Earth is round, I will never be found. $5 from Clit Rubs again. Taking Back Eden says, yes, MCTFE, thoughts on PBS Nat Geo curve fakery. $2.
Right. My honest thoughts on that is I have doubts what they did was legit. The way it's edited is sus, right? But I Toon, your thoughts?
Yeah, I mean, it was a TV show. It wasn't a scientific peer-reviewed experiment type thing. So it's a little different than that. But yeah, I mean, the editors of the video were putting stuff together in ways that weren't quite right.
Yeah, I think we need to point out though that nobody should really use that as evidence of anything because it is deceptively edited to make a point. Whether they got that result or not is kind of irrelevant. The way it's edited together is just the job of making it look good on a TV show. I would not use that as evidence because I don't think it holds up to scrutiny personally. And the fact that Stephen Hawking was involved in it was completely unnecessary, in my opinion.
Yeah, I don't know if we want to just escape it and just say, "Oh, it's because it's a TV show; it's allowed to be faked." I mean, now you've given.
I'm not giving them leeway to do that. I'm just saying that this is different than some sort of a a rigorous scientific experiment.
But it's seen by tens of millions of people who do assume that it is that.
Yeah.
So that's a problem.
Yeah, and if anybody uses that as evidence, I'll go after them too and say that that's not what you use.
The point is why you need to fake it.
He's talking. Go ahead, Flatzoid.
Sorry,
Flatzoid, go ahead.
The point is, why do you need to fake it if it's real?
Yeah.
To make it look.
Go ask the video editors that were doing it.
I've tried. They don't get back to me.
But I think we're intellectually honest enough to say that that's sus as fuck.
Yes. The worst thing that they could do is science is fake things. Flatzoid keeps reciting the gas law, saying, until placed in a container, by the way, says you are mopped. $5. Thank you very much. Flatzoid keeps reciting the gas laws, saying until placed in a container. This literally means gas exists without a container prior to you placing it in one.
No. That just means you require a container to have volume of gas. We have gas, a volume, so therefore we have containment. You can place a container of gas inside a already contained volume. It's like taking a fish tank and throwing it in a swimming pool and saying, well, there's no swimming pool.
Okay, we've got a Hammer, $2, says barometric formula has little g. Flat Z, explain.
Barometric formula has little g, yes, because it's based on how the air from the top is pushing down to push the mercury up. As I said, it's based on Boyle's law, actually, because it's based on how much pressure is being pushed down by the air, which still requires containment, which still needs a barometric. A barometer is containment anyway. It's not hard to understand.
Thank you, Clit Rubs, for being a member. He says they'll never understand until they take a stand for themselves. Hashtag.
So what was the name of that person?
You need me to say it again?
Yeah, please.
Clit Rubs. Yes, matters now. Matters now. Lorand Etvos, is that how you say his name? Oh, Etvos, showed that mass equivalence is an immutable law of nature, requires no container. SF6 falls. Mercury is a gas and liquid at room temperature.
SF6 falls, yes, until it disperses. That's called the arrow of time. We don't even get to that. The denser the gas is, the longer it takes for the gas to disperse. SF6 does evaporate and become vapor eventually.
It's already gas.
Have you seen what happens when you take SF6 and
but
pour it over?
gases can't evaporate. They're already evaporated. They're on the other side of evaporation.
They're very dense gas that dissipate. Sorry, yeah, that's the word.
Dissipate. Okay, good. I didn't think you meant that. That sounds a little
It is
too much.
20. It is 2:30 in the morning. So I'm
Thank you for being here. We appreciate that. Sorry, you need to go to bed. Sir Skippy 87, $9. He says MCTOON and Flatzoid. Sorry, MCTOON said to Flatzoid, "Do you realize the volume is always the same?" But later says they don't claim to have a fixed volume. You have to lie to Glurf.
Oh no, I'll be very specific. We don't claim a specific volume, but if there is a physical container, which is Flatzoid's claim, then the volume is the same all the time. It never varies.
Yeah,
right?
Toon didn't say that the Earth's volume is constant. I think he misunderstood what was said.
I'm applying the consequences of what an enclosing dome would require, a fixed volume that does not change.
And then I read Dalton's law. And then I read Dalton's law, which tells them they don't know what they're talking about. Yeah.
Taking Back Eden, $2 is MCTFE. How high ASL must one go to see Earth curvature? Be clear.
I'm high. Hi, how are you? Wait, sorry.
How high do you have to go?
No, nobody.
How high do you have to go to see the curve? That's basically what he's asking.
How high do you have to go to see the curve? Depends on your field of view.
I'll say that that you can get with an iPhone camera, you can take a photograph at 46,000 feet, and with some more precision type measurements, you can do it at lower elevation. But you need to control for lens effects. So a known straight edge would be something you'd want to do, but the camera would be it. But to see with your own eyes, yeah, more than 40,000 feet,
or at the ground level if you're looking at Lake Pontchartrain, right?
Front to back versus left to right is different, and I assumed that the question was about left to right.
Okay. MCTOON loves to use the word strawman. Could he please define the definition of strawman, and how did Flatzoid try to strawman the globe? This from
so
Roy.
Strawman is
good.
Yeah. It's redefining the other person's position in a way that makes it easier for them to attack, and then they attack that version of the other person's position instead of the actual position. So since we don't claim that there is anywhere in the universe that has zero pressure, then we don't have as part of our position that there is some sort of requirement for a physical containment of gas pressure. The entire universe has gas pressure, so there's no area. There's
we never said once there's no zero pressure anyway, by the way. So you just strawman your own strawman.
So, well, but the assumption of your gas pressure requiring a physical container is that on the other side of that physical barrier is the zero pressure area, which we don't claim. We claim there's always positive pressure everywhere.
Never said that. It's a separate system.
Awesome. Then we're in total agreement. There's no necessity for a physical container.
And if we put something out in space, would it register as there's pressure?
If what?
We put something in space, it's going to register that there's pressure?
Yeah, if it's precise enough.
Okay.
Yeah, my phone wouldn't. It's not a good enough barometer.
Gotcha.
So this postulation of this is sort of like, why don't we just discuss a +4 elven sword and its damage that it does to a common orc? You know what I'm saying? I mean, you're talking about shit that doesn't even
Craig, pull it. Craig, does some play D&D?
He must.
He must. Dude, I don't. I'm starting to like him. I'm liking him a little more here. I was gonna say.
I knew a lot of D&D nerds growing up.
Do you have your own D20?
No, I do have some of those polyhedral dice though.
Oh, that's I got a full set
box of shit I got.
Wow.
And
why do you have boxes of that stuff around? That's weird.
No, I don't have boxes.
That's really weird that you have boxes of that stuff sitting around.
Well, we're going to talk about kind of weird, really? I have toys in a teenage boy's bedroom that I broadcast from.
You're in a teenage boy's bedroom? What are you doing in a teenage boy's bedroom?
I mean, look at that. You're what, like 50, and you got
I'm 13. Thank you. 13, please.
Can you put back on the hat?
There you go.
The hat that was look like both of their haircuts? That's pretty cool.
Oh, I have that. Yeah, that was an honor.
Yeah, it was the
That's
Jimmy Neutron hat.
That's not the.
That's kind of like your guys' haircuts, if you look at it closely. All right,
this is my Craig hat, man.
Craig hat.
Yeah, we almost called you Felicia the whole night.
All right,
sorry. 3
Jared,
Ron.
if you're gonna be talking haircuts, you're gonna have to show yours.
Oh, I'm bald. Come on. I mean, well, I have hair, but I just shave it. 3 Ron. Toon, FTFE, thank you for standing up against incompetence and lies. Okay.
You're welcome, 3 Ron.
Yeah, if only they had any evidence to back up their
Remember,
claims.
stupidity is not a right. Fight the flat Earth.
Thank you. LJ499 says fastest. Oops, I lost it. Fastest. Nope. I went way down low. Where are we at here? Okay, we have a lot more to go through. Fastest bullets travel 2,000 miles per hour, and rockets travel 17,500 miles per hour to leave Earth. How can humans and ships remain safe going 8 times the speed of flying bullets?
Wow.
Well,
relative velocity is the problem for them, I guess.
So humans only feel an acceleration, so that's why when astronauts are in the rockets going up, they're all like because they're accelerating to that 17,000. But once they're at 17,000 miles an hour, they are going 17,000 miles an hour with the rocket. So that's the thing.
I mean, people in the Concorde were going 1,000 miles an hour and sipping their champagne. So it's not about velocity; it's about acceleration.
A lot of bullets.
Yeah. Because you can take your time to get to that speed, and it's not really going to cause that G forces on you. That's how fast you get to those G forces.
Although they do get to it pretty fast, and it's not comfortable.
I got a question though.
That would suck.
I got a question though based on that. If the globe is going in different vectors at different speeds, why aren't we having different accelerated rates?
You sum the vectors.
Yeah,
that's what vectors do. Yeah, you sum them.
Very, very, very small.
Okay, we've got
those different movements gives a tiny acceleration.
LJ says, even my dog knows all the moon landings were faked. And
LJ rocks.
By the way, 3 Ron and Royd's X31 were the ones I forgot to mention earlier. Okay, we've got nice moderation, enjoyable debate. Thanks, Sharon. Thank you very much for Retro Bill, $5. We've got Veritas, $5, says how can flat earthers say with a straight face that all the things that effectively all scientists accept violate all the science?
What science is he talking about?
A little bit of science.
What science?
Yeah, we're talking about natural law here. You haven't established anything that can show to violate natural law, which the globe claims to do.
Let me laugh.
The globe not claim to violate natural laws.
Oh, yes, you do. No containment.
None of those people that wrote those laws down and figured those laws out agree with your assessment of their laws. None of them. Not one of them.
You ask them?
I highly doubt. Noted that all the demonstrations and experiments anybody has ever done required containment.
Mandela effect. Jonathan Bardsley, $2 says, should get them to swear on the Bible that they will not lie.
It wouldn't really matter for them.
I can answer that one.
Okay.
Mandela effect. Johnny Bardsley has not read Matthew 5:36, and do not swear by your head, for you cannot make an even one hair white or black. All you need to say is simply yes or no. Anything beyond comes from the evil one. So I will say, yes, the earth is a globe.
Okay.
I mean, if someone sticks a Bible in my hand and says, swear on the Bible, the earth's a globe, I'd do it. It means nothing to me because I'm an atheist, but I mean, I'd do it. Okay. I don't happen to have a Bible in my house.
Good stream, says Melissa Schultz. Thank you very much. $5. We've got Stephen Jarvis. $2 says Flats. You are young enough to witness space travel. Flats. You are young enough to witness space travel. Okay.
Like he's young enough that he could go
didn't
to space?
Say 50 years? Didn't they say 50 years ago they're sending people to the moon again, and still nothing?
No, 50 years ago they said they're not going back to the moon right now.
No, they sold tickets.
Yes.
Pan Am sold tickets
they
to the moon.
Keep pushing it away. No one can get to space. They can't even get past low Earth orbit today.
Low Earth.
It's coming though. It's coming.
Yeah.
It's coming.
Aye.
Where did Slav go? He keeps messing up the screen.
Right
Slav,
here.
you're destroying my screen. I'm sorry. Monkey,
keep your camera on. Just cover it if you need to turn off the camera.
Put a blanket over it or something.
Well, I just duck down when I need to do a bong. You know?
Monkey,
there you go.
that's I was wondering what you're doing down there. Monkey Cat Pat Pat. That's the funniest thing I've ever seen. $6.66. Here's a tip. I disagree with you, but I like what you do. You and Takori are the only flat earthers I'd have a drink with. Who's Takori?
I debated Takori last week on Modern Day Debate.
Oh, I did see that. Okay.
He's a nice guy. I like Takori.
Glenda Sofkin, thank you very much. $10. We've got Ethan W0406 says, Craig, from Wikipedia, the burden of proof lies with the one who speaks, not the one who denies. Is the obligation of a party in a dispute to provide sufficient warrant for its position? WTF, dude.
Well, yeah. Again, stating the claim that is fake.
That's speaking.
Yeah, that's a positive thing that they've spoken. And in logic, the burden of proof doesn't always lie with the person making a positive claim anyway. If you're having a conversation and two people are making positive claims, the burden of proof would actually lie with the claim that goes against the status quo, not the one that doesn't. So, logic isn't as black and white as flat earthers seem to make out.
Okay. We've got Mag Chameleon. How did the moon eclipse the sun moving from west to east of the moon normally moves from east to west in the sky?
The orbit of the Earth, the rotation of the Earth and the velocity of the moon around the Earth are different. And that's why it goes the other direction, because it's not just the orbit of the Earth that you're seeing. It's the relationship then between the sun and the moon velocity. So that's what's going on. It's that particular motion was predicted decades ago, centuries ago, by the globe. And so specifically, you can look at VSOP 87 ephemeris and ELP 2000 ephemeris and use those to determine where each of where the sun is, where the moon is, where the Earth is, and it will give you the position and the direction of the eclipse for the globe.
Angle of elevation.
And the claim that it's different, it did something different in the eclipse, what it normally does is just false. So, yeah.
Angle of elevation says Elon Musk is selling tickets to Mars for only $100,000. Has MCTOON and FTFE bought their ticket yet to prove this space religion?
So Elon Musk is not selling tickets for $100,000. Musk has said that in the future, possibly once there is economy up and running, tickets could be as low as $100,000. Not that he is currently selling them for $100,000. Elon Musk, although he's done a lot of great things, I don't think anyone takes all of his claims about Mars that serious.
He's partially a salesman.
Yeah.
So don't yeah.
He's not one of the richest men in the world, but
okay.
A lot of his claims need higher scrutiny than people are giving them. Although, thank you for my internet. I do appreciate it.
For science, would you, MCTOON or FTFE, like to get undressed and measure length and big balls curvature with Brenda? That's nice. I don't think you need to answer that. Veritas $5 says,
"Oh, you got to do that, guys."
Are they embarrassed?
Oh, that makes me think of matters now. Ooh.
Oh man,
not nice.
You're thinking about size, dude. I don't know about Ozian, but okay,
Yeah,
if you're thinking about Ozian.
Are they embarrassed?
No. Thinking about when I debated Brent.
Why are you thinking that about him, Flatzoid?
No,
You've got a wife. Naughty Flatzoid, you've got a wife.
See, that's
and
cool.
I'm pretty sure
Strawman.
that Ozian is also taken.
That's called a straw man.
Or the pizza pie Earth is a straw man as well. Are they embarrassed that none of them can show the dome when this would be the most significant discovery in history and trivial to show?
Yeah, it's easy to show. We're breathing, therefore containment.
So that's not the dome.
No, he's asking for the dome.
As Flatzoid pointed out, if I'm sitting down having a T-bone steak, I know that steak came from a cow. I don't have to see a picture of the cow to know that steak came from a cow. I have steak in front of me, therefore there was a cow involved. I have gas pressure. I have gas in a volume, therefore there is containment. Because, as everyone knows, in order to have a volume of gas, it must be contained. Mm-hmm. This, of course, causes pressure.
Affirming the consequent fallacy. Good job.
You're
It's
a phallus.
simply law of nature.
LJ,
Affirming the consequence fallacy.
$2. What
Law
would?
of nature is not affirming the consequence.
Oh, this person. Sorry, I
No,
almost
you
missed you,
literally
Lowry.
affirm the consequence. You've got a law of nature, but you affirm the consequence. So, yeah.
Lowry, $10. Stop the apologetics bullshit and address water level and engineering, and particularly canals around the world. I can't believe I have to give money to address this. Seriously. Sorry, Lowry.
Or it's me, or us, or them.
That's you.
You guys, because water lies level when at rest. Canals show
Yeah.
a long distance of level flat water.
It's us. Yes. So
And that's for us. Yeah.
Yeah, level isn't flat. And in engineering, we have actually shown that water curves specifically demonstrate in tow tank facilities where the railing above the water.
Oh, what was
has
the
to
name of that
stay-
place? I wanted to look that up. I didn't look it up last time.
Many, I have to send you a list of them that I've put together, Jaren.
Do you remember one? of them? Oh, yeah, I
but
just want to
yeah,
know the one. That you talked
so,
about.
sea level also around the world is different depending on where you are. If we look at the Panama Canal, for instance, the sea level is different from one side to the other, which is interesting. Water, in fact, has never, ever, 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 ever been measured to be flat. And I have asked flat earthers for this measurement, and in fact have said if they can give me a measurement of water being flat, I will hand them £1,000.
So I'll go with this. Remember that who brought up the definition of what was it? From burden of proof. That was Ethan W. Said burden of proof lies with the one making the claim. So if you're claiming that water is flat, then you have the burden of proof to show the measurements of the flatness of water. And I've never seen that either. So.
Or I can bring the definition that says synonym, flat, level, horizontal.
And we're not talking about synonyms. We're talking about
There we go.
the evidence. The
Flat,
evidence.
why flat?
It's not just a word game.
Level is
It's
a
just a
measurement.
word game.
Level
if
is
you don't
a
have
measurement.
if you don't have measurements, just wave the white
We
flag.
do.
What would be the
and try
measurement?
to
Zero?
obfuscate away from the measurements that you don't have.
Hold
We
up.
do have measurements. It's
But
level-
then let's.
level-
I'll be
hold on.
anxious to see them.
Toon, level is a condition. Convexity is a shape. Sorry,
Mhm.
buddy. You want to know
No,
what the
that's
measure-
not a
you wanna
measurement.
know what the measurement?
That's
of
not a
level is?
measurement. You
Level-
have the
you wanna
burden
know
of
what
proof.
level is?
You have the
Level
burden of
is
proof.
level. Okay.
Yeah. You have the burden of
that's
proof
what
to
that
show
is.
it's flat. You're
That's-
claiming it's
that's
flat.
Either is or
You
it
have the
isn't.
burden of
It's
proof.
very congruent. It's very congruent. It's
Hmm.
either
Good.
is or it isn't.
Just show the measurement.
It's a horizontal line there.
Just
As
show
far
the
as
measurement.
point A to point B.
All
is
of those are
horizontal.
claims. According to
As
Ethan
far-
W., you have not yet substantiated your
What is a
claims.
measurement of
As
flat?
far as
on you.
What is it?
the horizontal, as far as the horizontal is from point A to point B, it's measured flat. There we go.
There's a claim.
Level.
Now you have the burden of proof.
So,
Okay.
what is a sufficient measurement that you what units is that measured in? Flatness. What is that measured in?
It would be a deviation from a straight line in
Okay.
in a
So we
linear
don't have
measurement.
that.
So
So
centimeters.
we don't have that. That's the problem.
Yeah,
See?
yeah. So show the measurement of the non-deviation from a straight line. That's it.
We already
There,
demonstrated every day.
I just did. A ruler on a table, flat table. There we go. Next.
Oh my goodness, that was amazing, Flatzoid.
Okay, we got from LJ $2. What would it do to your career if Earth is 100% flat? I guess it's to you.
I write email software. It wouldn't affect anything.
Yeah,
Craig?
I mean, I've got my OnlyFans, so I'd be fine.
God damn.
Awesome.
You think I'm joking?
I know you're joking. Hammer. To repeat, barometric formula has gravity. Nothing to do with pressure. Care to explain?
Sorry.
Wait, say that again.
To repeat, barometric formula has gravity. Nothing
Yeah.
to do with pressure. Care to explain?
But it does have to do with pressure. The barometric formula gives you the pressure.
Yeah, barometric pressure
Pressure.
in the barometric formula has gravity. Okay.
Sounds good. Thank you, Hammer. $5. We got $10 from Upside Down Guy. He says, FTFE McGoon, would the flat Earth theory work if there was no enclosed atmosphere in an infinite plane?
Would the flat Earth theory work if there was no enclosed atmosphere in an infinite plane? There would have to be a reason the atmosphere stayed there. You know,
That's what he's asking, basically.
I don't.
The question's a bit odd. Would the flat Earth theory?
No enclosed atmosphere.
Right, so he's kind of throwing it
I suppose.
back in.
I suppose. Yeah. I mean, you'd have to have air everywhere, But if it was not enclosed, then according to Flatzoid and some here, it wouldn't work because it would all go wherever the non-enclosure is because there's no gravity. So you wouldn't have any air. Unless Upside Down guy thinks that gravity does exist. It's confusing what his position is.
I think it would depend if there's a separate system or not.
That makes no sense. Thank you for that.
Okay, we've got Sir Skippy87, nice name, $5, says, Jaron, please pull up a Latin to English translation tool online and type in the Latin field scientific. You know what that is? Before I type it in
Scientific?
Oh, well, that's crazy. I want to see that. I got to see this. Latin to what?
It comes up with, like, if you sci and or something, it comes up with something about a lie or something, but, language isn't, and then Latin isn't.
Yeah, I showed that Nickelodeon means there's no God. E-N-T-I.
Yeah. Do you know where Nickelodeon actually comes from?
Yes, it's the name of a old theater.
Yeah. It was a nickel to go and watch it.
Yeah.
So that's where it comes from. But people put this weird thing on it that I don't understand.
Yeah.
So I get in 3 different translations, no being thick. I don't know. Maybe there's a different.
Oh, know that it is fiction. Is what I had.
Oh, okay.
That is crazy. Okay. Thank you very much. Oh, I want to see that. I don't know if people want to see it. Just go to, I went to translate.com/Latin to English and put scientific. And it comes up. Know that it is fiction. All right. That was awesome. Let's go with.
Scientific is fiction. Cool. Yeah. There we go.
Yeah. LJ says, is NASA the only government that doesn't lie?
NASA aren't a government. NASA work.
But they're people. So they do what people do.
Hey, that's good.
Yeah,
okay.
NASA.gov.
We've got.
Thanks for the website, Flatzoid. Nobody knew. Good job.
Yeah, personally,
the fact that it has a .gov extension should tell you.
It's government. It's government based. Just like we in South Africa, we have ESCOM. It's electricity. It's government.
Yeah,
super.
It's just a sector in the government.
NASA aren't a government. They are.
No, they're part.
Do they get? Does NASA get tax money?
A lot.
But that doesn't make them a government.
Thank you.
Why do they have a .gov?
But Craig, it's just a word. It's not a gotcha because they got weird on the English there.
Be nice to the supercharged
domain.
It's part of the government. We're not disputing that. It's part of the government.
I think all companies should get tax because if you just put .gov there, you should get everyone's tax, and not be government. Okay.
All right.
But to answer the basic question, I have never been presented anything from NASA that has been verified to be a lie.
What do you mean? Haven't you seen the Mike Collins photo? The Mike Collins one that they lied about and said that he was in space, and then they found the photo and he's not in space. He's in a blacked out room.
So was that a lie or a mistake?
They put it in the press readings. They put it out as he was in space.
You don't accidentally not tell the truth.
Or what happens when he says he didn't remember seeing stars in space, and then later in the book, I remember seeing the stars. That's also called a lie.
Have you never revised your statement there? I'm glad you're the only person ever that's never revised a statement.
Well, he just made the claim that he's never gotten anything from NASA.
Oh wait, I didn't witness the murder.
That's just crazy to say. Never.
That's pretty big. Okay,
wrong.
It's not like I don't know. Come on, man.
All right. We've got here. Oops. Sorry, I got lost again. We're down here. MCTOON, why do you? Oh.
No, it's LJ. Does the water inside of a swimming pool lay flat?
Where are we at here? I lost my place.
That's
LJ. Oh, that's what you're on the screen. Yeah, but up here, did I miss a few, or am I just way back?
Yeah, I think you missed a few back before that.
Okay, I'll find them.
But they scrolled off my screen though.
So this one here, Craig, we read that one. We read How Does the Moon Eclipse the Sun? Yeah, we read that one. Elon Musk, we read that one. Then we read. No, my screen is not moving anymore. Come on, move. Okay, my chat is frozen. There we go. All right, so we've got that one we did. The pressure gradient is proportional. Okay, this one. Are they embarrassed? None of them can show. We'll do this one for now. Are they embarrassed? None of them can show the dome. Nope, we already read that one. Pressure gradient is this one we haven't got. Pressure gradient is proportional to the sound vector acceleration according to Euler's equation. A set of quasi-linear hyperbolic equations governing adiabatic and inviscid flow and fluid dynamics. Who is that supposed to be to? Anybody have any comments on that?
No idea.
Force just means the pressure goes due to a force of movement.
Okay.
Force creates.
There's no such thing as a. What do you mean a force of movement?
A force causes movement, which gives you a pressure gradient. That's what he's saying.
Pressure gradient.
Thanks, gravity.
Yep. You need a force.
Okay, November says, McToon, why did you try and sabotage Austin's debate with Harrison? If your worldview is self-evident, you probably wouldn't be so scared.
Now, I've seen people say that somehow they think that I called in. I did not call in. I don't know why people thought that. I thought it was kind of funny.
Well,
I didn't try to sabotage it at all. I was excited for it.
Yeah, I'm not sure how they think you sabotaged it. That's a bit weird.
The rumor was that it was said, don't have the debate, it's a trap.
That's not what I said. That's not what I did. I don't know where any of this came from.
So you never said it was a trap?
No.
Okay.
So you didn't call, or you didn't know that's not what you said?
No. So on Twitter, there's a bunch of flatties on Twitter were claiming that I called into InfoWars. They said. I never did. But I think it's funny that they had to put that on me as if I did something when I didn't.
You didn't message them or anything?
I mean, they have to have evidence for that.
So what's that, Jerry?
I just said you didn't message them or anything. You said you didn't.
I sent a message to Harrison saying, "Don't go unprepared."
Okay, but no word.
And
trap.
it wasn't. He didn't respond to me or anything. But I said, "Don't go unprepared," because you've seen it, Jaron. You've hosted some. People will come in without knowing the types of arguments that flat earthers are going to claim and are just baffled by the nonsense. And people are like, what the hell's going on? I don't know what you're talking about. So,
but I don't agree with that. I mean, look at tonight. We talk about.
Yeah, I mean, you guys got crushed.
We showed all this stuff we always talk about, and you still weren't able to understand what was going on.
Oh, you're adorable. You're adorable.
We brought up citation. You didn't. So no.
Citations you up.
All right.
Okay, we read that one. Jaron, please. Okay. LOL, NASA is the only government doesn't lie. We got that one. Does the water inside of a pool lie flat?
No.
Yeah, there's little waves on it all the time. But if the Earth were flat, then it would, and somebody could potentially measure it. But the margin of error of that is pretty small. So you'd want to probably do a larger area than a pool.
Okay. Flatzoid and Dave won the debate hands down. Mike should have waved the white flag earlier to save face.
Oh, that's cute, Roids.
It says Roids times 381.
Adorable.
You are mopped. $2 says, just saying, what's up, everyone? Thanks for the show. Thank you. You are mopped.
You are mopped. Shout out to your mop, by the way. Awesome channel.
All right. I don't think I followed it. I'm going to follow it after. Anthony Simpson says, Craig, even in your simulation, there was a container. You have to not only get rid of the lid, but the walls too.
No, I took rid of the lid. But
he's saying you have to get rid of the walls.
Oh, right. Okay. So how... The question I've asked flat earthers then, because they try to it's still a container if it's open. Yeah, but how many walls does a container? You know, you can't. Oh, it's open. It's closed. It's not a container. It is a container. The fact is, I took the lid off. It was open.
It's
with
no
gravity
longer. On all
there.
sides.
No, but can you please still tell us what is the right amount of gravity? Because what's lots of gravity?
One.
That was a simulation. That was a simulation.
It isn't based on reality.
Flatzoid, it wasn't. Dave brought up that very simulation. So go question Dave about it.
Let me ask you something. Can you go get a bucket of propane to run your grill? Can you go down and buy a bucket, or do you need an enclosed container?
Oh, you don't understand this topic.
Okay. Anyway, yeah, what Dave showed was based on actual demonstration of gas behavior. What you guys showed was, let me put something that's not real, aka lots of gravity, because you can't even give a quantization for that gravity because it's not real.
One.
Yeah, one. That's a good. That's a number. It is a number.
Okay, so you're claiming that lots of gravity is 1G then? Is that what you're claiming?
Yep.
Okay. Be sure to back that up, okay?
I don't, Flatzoid, I don't know how you didn't get this, but that wasn't actually individual particles of air and applying the actual mass of those individual particles. That was just a simulation showing what happens when you have gravity and don't have gravity.
So not reality then, exactly.
Cartoon.
We can actually, in my simulation,
brought it up.
I can add a lighter gas too to the mixture and show that the behavior changes.
Yeah, and the lighter in gravity. the lighter gas goes to the top. And
So,
in
guess
reality,
what?
the
It
lighter
doesn't
gas
go to
goes
the
to the
top.
top. In
Guess what?
reality,
It
it
doesn't.
does.
No, it
In reality,
doesn't.
it does.
No,
Yeah.
it doesn't.
Have you ever checked when they take?
Oh my
sulfate
goodness! You
chloride in
don't?
a fish
Are you
tank?
serious? You don't think that? Are you?
Have you
Are you
ever-
that?
Can
Seriously,
you? Can you?
I just
can
want to
you-
know.
Just go ahead and demonstrate it.
Actually,
Go ahead.
don't.
You're making a claim. You made a claim, so
Yeah,
demonstrate.
all
it.
right. When you release helium from a tank without a balloon or anything, it
Mhm.
goes up.
Does it keep going up
in
or
all
does
directions.
it stop?
Wait.
It goes up. It
It
settles
goes
to
in
the
all
top.
direct. No,
No,
it
it
goes in
doesn't.
all
No, it
directions.
Yeah, it
doesn't.
does.
Flatzoid.
All
The
directions.
Goes in all
the
direct- yeah, it
helium
does.
goes up. It does
All
not go down.
Wait, but then how would we
It
have
doesn't.
air to breathe? Wouldn't it have all the heavier gas at the bottom and the lighter gases up top? Why do we have a mixture?
That's generally what happens. There's mixing and stuff,
Oh.
so it's not just a layer of carbon dioxide at the bottom, which is
There
heavier
you go.
than oxygen and nitrogen.
There
There's
you go.
mixing, but the helium goes up. We don't have helium right around here.
Doesn't go
Because
up
it's-
as a
it's a-
unit. It doesn't go up as a
Of
unit.
course, it doesn't
like-
go up as a unit.
No,
That's
it does,
how
what
gas
happens
works.
to it? What does it do?
Yeah,
Go ahead.
it
What
goes
does
up.
it do?
It disperses up.
It
disperses up.
Okay.
Because the
Does
heavier
it
gases are
continue?
down
Does it? At what point does it stop?
when it hits equilibrium.
Okay. Why? So not gravity.
Yes, gravity. Gravity is,
No,
is
it's
one of the
equilibrium.
forces in that
You
equilibrium.
literally, you
Gravity
literally
is
say
one
that
of the
gravity-
forces in that. Shh, Flatzoid, he's talking to me. One of the forces that determine that equilibrium is gravity. There's other
No.
forces at play. There's upward and downward forces. One of the downward forces is
You're
gravity.
literally claiming gravity can overcome entropy, mate. Literally, that's what you're claiming.
No.
It can
Oh my
in
gosh.
certain-
You
That's
you
the-
still have
my
not
gosh.
demonstrated
Oh my gosh.
whatsoever gravity.
The straw man. The straw man. Here comes the straw man.
What straw man? You're claiming that gravity pulls gas down.
Of course it does.
Definitely.
Yes.
Okay, well then prove
Yeah.
it. Let's
Yeah.
demonstrate it. Show it.
A scuba tank that is
A
full
container
versus a scuba tank that is not full has more weight.
A
Has
container.
Volumetric
and-
is
and-
that calculated?
container.
Volumetric it's volumetric.
no, it's not volumetric. It's weight. I said weight, not
Volumetric,
volume.
yeah.
Flatzoid,
Gas
you
is
put it on a
volumetric
scale.
in con-
You put it on a scale, Flatzoid.
We brought up
You
citation.
take
that said
it, you put it on a scale, Flatzoid. Do you
Okay.
not know how to measure weight? This isn't difficult.
Wait a second. Wait a second.
calculate it. You can't
you-
measure weight of gas. You can only calculate
Of
it. in a
course you can
container.
measure the weight of gas.
I literally
Of
brought up
course you can.
citation. Dave brought up citation that showed you this in words, literally on screen.
Literally, you don't understand the topic even remotely.
You can't
Flatzoid.
read,
I'm sorry for you. Don't teach your kids.
The
So
physics.
I noticed that you
Ah.
had to put the gas in a container. So it's in a state of disequilibrium, right?
If you want to measure a certain amount of it, but your
What if the-
claim.
wait, all right, wait a second.
Let's be
wait a second.
clear,
What
Dave.
if-
Your claim was that you cannot measure
All right,
the
well, all right.
the weight of gas, and I said you can. I gave you an example, and you moved the goalpost.
How much?
You have to
how
move the
much-
goalpost.
Wait.
Move the
How much-
goalpost again.
No,
Here comes.
no.
Move the goalpost.
I'm gonna stay right on with it.
No, you're gonna move
So
the goalpost.
let's go with the tank. We're gonna have that tank, but we're only gonna have it at the same pressure as it is outside of the
Okay.
pressure. Okay.
Cool.
Now, what's the weight of that going to be? I mean, is the weight is going to be the same as the tank because the tank would be
Yeah.
considered empty,
Yeah,
right?
So then
but
tear your scale.
there's still
Tear-
air inside of it.
Got it.
The
Now,
tank
tear
would be
your
considered
scale.
empty.
No, it wouldn't be empty. It still has air in it. You said.
That's right, it is, but
so,
it's
so
not
pump
under
out
pressure.
the air. Pump out the
You
air.
can't. You can't pump out all
can't.
the air. There's
You
always
can't
air.
exactly. That doesn't change the
There we
reality
go.
that it has. You are
Volumetric
claiming it
calculation.
does not. David, your very specific claim is that gravity isn't affecting air, and it
It's not.
definitely does.
No, it doesn't.
Okay.
Hey, guys, sorry, can we
You're able
move
to
on? It's
show a
3 o'clock.
downward
We're moving on. Let's go.
pressure.
I know he's got to
I've
go to
got to
bed.
get up in an hour and a half for work.
Okay.
Run away.
The physics around docking rocket ships gets me excited. Does catching up to a 17,000 mile per hour moving ISS and slowing down and docking seem feasible, and how?
Newton's laws of physics, Newton's laws of motion deal with that.
Okay.
Like
It's relative velocity is not a problem. Galilean relativity, it's not. No, nobody questions that. Like
MCTOON,
you can play catch with somebody while riding a bus across the aisle. That's
okay. MCTOON is a narcissist. Another win for Flat Earth. MCTOON, you can celebrate that one. Awakening
I don't know how
Minds.
I don't know how that changes the shape of the Earth.
It does not. $5 for Awakening Minds. He says a level is used to mimic our flat horizon, hence why it's used to hang pictures correctly. Globers, what tool do you use to level objects? And that is the last one.
The first bit of that was not true. A level is not used to mimic our flat horizon. That's something that I would definitely smack the citation required button on.
Yeah. Yeah, a level gives you a level just for that particular location on Earth, and we've measured that level diverges at different locations.
Okay, we'll let Keith go first. Keith, say goodbye, where they can find you, where they can watch your stuff, please. Thank you for being here.
Awesome. Thank you very much, guys. This was fun, but I have to get to bed. It was awesome. Thanks, Jaron, for this, and Dave and you guys as well. It was great fun. You can find me on Flatzoid's Perspective, YouTube, Instagram, Twitter, X, and on, yeah, I think that's it. But thank you guys for coming. Really appreciate you all. I'll see you again next time.
Okay, and Saab, go ahead. Say where they can find you.
All right. Well, you can find me on Rumble at Sovereign Soul, or SSUM369 on Rumble, and also at Sovereign Soul Unchained Mind on YouTube.
Okay, Craig, where can they find you?
You can find me at youtube.com/FTFE1, on x.com/FTFE official, and obviously if you like my OnlyFans, you can ask me for that link.
Goodness gracious. Puke. Mike.
Just search for MCTOON wherever you're at. You'll probably find me.
All right, we got a busy week. Tomorrow we've got Craig is coming back. Who are you going against, Stuart?
Stuart Buckle.
Craig against Stuart tomorrow. That'll be at 3 Pacific. And then at 6 Pacific tomorrow night, we have Speaker's Corner. So join us for that. Send me a message on Telegram if you're not going to be able to attend and want to get your 4 minutes in. And Friday we have my show. Saturday we've got the VIP only hangout. So busy week. All right. Appreciate you guys being here so much. We'll talk to you guys soon. I remind you to do your own research. When you do, you'll never again believe all the bullshit you've been taught. Till next time, this has been Jaron and all these guys and DEBATISM X. Peace.
Thank you.
Thanks, guys.
Yeah, it was nice just hanging out. Now go and hit the bell. Share it with the homies so that they could grow as well. They missing out. Jaron leaves no doubt. If you know what we bout, it's never for the cloud, don't fuck around. Hey, not for the clout, that's too cap, we calling them out. Balls get flat when you cover the route. Jeranism all in your mouth. Truth gets lost like all on the couch, but it's time to get up and make them get out. Uncover the route. Jeranism, we are the crown. Telecasting worldwide, check the globe, it's falsified. Space is spinning, DFI, all just scientism lies. Telecasting worldwide, check the globe, it's falsified. Space is spinning, DFI. All just scientism lies.
Who this be? What he about? You stay spinning, he stand out. About flat earth, it's flat out. He's still standing when you pass out. Globers pound, screaming, shout. He can turn you inside out. Yeah, surface deep, he's felt throughout. And he stay grounded, you spaced out.
We gotta run nowhere when we come fact check your facts and match your data. Concept is too abstract, what matters? Try to tune in, but the note get flatter. Tell me I'm flattered. Flatter than pancake batter, now we landed. Jeranism, I'm your captain. Speaking, telecasting worldwide. Check the globe, it's falsified. Space is spinning, DFI, all just scientism lies. Telecasting worldwide. Check the globe, it's falsified. Space is spinning, DFI, all just scientism lies. You know equations to the things you make the symbols for, but ain't really explaining what the symbols for. They try to teach you things against the things we taught before. No point in arguing now, they don't wanna talk no more. Okay, got a bite of the truth and now it's certain. That's what life look like when your mind is certain. Okay, got a bite of the truth and now it's certain. That's what life look like when your mind is certain. Thanks to the east side, thanks to the west side, thanks to the north side, way down to the south side. Thanks to the east side, thanks to the west side, big up to the north side, way down to the south side. Telecasting worldwide, check the globe, it's falsified. Space is spinning, DFI, all just scientism lies. Telecasting worldwide, check the globe, it's falsified. Space is spinning, DFI, all just scientism lies. Telecasting worldwide, check the globe, it's falsified. Space is spinning, DFI, all just scientism lies. Telecasting worldwide, check the globe, it's falsified. Space is spinning, DFI, all just scientism lies.
I'm here with Alex Stein. Alex, what do you think of people who don't join my VIP club?
Guys, join the VIP club, $15. If you can't afford that, you need to stop watching YouTube and go freaking get a job. But if you can't afford it, come hear some truth.